My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
So, I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired. Because of Google Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the Glue Cloud team.
Welcome back, everyone. It's Mike Gibbs, and we are here for day 5 of the Go Cloud Careers AWS Solution Architect Associate 2024. This is to prepare you for the AWS Certified Solution Architect Associate exam, and it is the SAA-C03 certification number. So hopefully you're here. Hopefully you've seen some of the previous few days, and if you haven't, don't worry about it. You can go back and watch the videos. I encourage you to share this video with friends and invite others so we can truly help more people around this world with this free AWS full course. So we're going to have some fun today. So let me know where you're at. I see some people in Cameroon, which I'm totally excited to see. Of course, we actually have our teammate, Eddie, who works for us, who's a great cloud architect living in Cameroon. I see somebody in Zimbabwe. I love that. I see some people in Colorado Springs and some Phoenix, New Jersey. My wife's actually, she was in New Jersey this morning. Now she's in Philadelphia, and she's hopefully coming home to Florida if that allows. George over there in Miami, fantastic, so close to me. Hi, everyone, you're just joining. That's okay. Welcome, welcome, welcome. And you can go back and watch the other ones. It's great. Mark, it's always so good to see you over there in San Francisco. Ben over there in New Jersey. It's wonderful. And Adrian's there in Phoenix. Fantastic. Welcome, George. I see Adeyemi's in Nigeria. I love that. Preb, I know he's over in there in the U.S., but I know where Preb's from. And hi, everyone. It's good to see you as well. So welcome. That's right. You're in Sacramento. And Eddie over there is in Bamenda, Cameroon. Hasnat is in Cypress, Texas. Cypress, Texas is good. Cypress is real good, too, as well. And saw that one coming from Nigeria. I love this. And another person in New Jersey. And so we will have some fun today. So we're all here. Let me tell you, in case you just joined, if it's your first day. So in order for us to really give you a good AWS Solutions Architect Associate course, we are going to learn something. We have to focus on the concept. So I've interviewed about 6,000 technology professionals to find them, and I can always find somebody that can click a few buttons or write a Python script. That kind of thing is easy to find. What is near impossible to find is someone that understands the technology, knows what the technology is, know how the technology works, know how to apply that technology to solve problems. Those people are worth their weight in gold, diamonds, and platinum. They're impossible to hire, and when you've got those skills, you've got good earnings. So I want to spend a lot of time on that. But accordingly, I still want you to get hands-on. So sign up for the completely free hands-on labs for you to do them at your own time. If you just got here and you're enjoying the content, please hit the like button. And if you're not a subscriber, please subscribe and hit the bell to be notified of new videos for you. So, we've talked a lot so far. We've talked about the way the cloud was organized. We spent a couple days on cloud networking. We talked about databases, and we got pretty deep in databases. I had fun with it. We talked about Kubernetes. We talked about container, other forms of container orchestration. We talked about virtual machines. We brought you into our data center and brought you into a VMware environment so you could see what enterprises are using, so you could truly understand what is a virtual machine. And we talked about some other things. But now we're going to talk about serverless computer functions. So we're going to start with that today. So make sure you've got it. And also, we've got a guide on how to look at certifications. It's completely free, and it's in the description of this video. And we've got a lot of other free stuff in this video. So description of this video. Webinars on how to become a cloud architect, which is different than getting certified. Webinars on how to earn more in your career. Free ebooks on, for example, how to win the interview. So all this stuff is free. Go get it in the description of this video. So now we will begin with serverless functions and Lambda. Before we begin, Lambda and serverless is a tool. The difference between a great technology professional is being fair, being unbiased, and evaluating all the situations before you make a decision. Serverless is just that. You will see people that are all in for serverless. They are dangerous. You will see people that are all in for never serverless. They're also dangerous. What we actually need are people that are going to look at the problem and then select the right tool to solve the problem. A carpenter doesn't use a hammer for everything. They use a nail gun, they use a hammer, they use a saw, they use a screwdriver. There's all kinds of tools that they use. Same thing. So serverless is a tool. Now, each cloud provider has their serverless, and we're going to talk about AWS Lambda, but I want you to understand the way these things work is you basically give it your code, and every time it runs, they charge you. So when it comes to thinking about using serverless, if you're not going to use it a lot, serverless is going to be very cheap. For example, you may have an event-driven architecture where if this happens, then something happens. So maybe a user puts something in S3 or the object storage. They make it public when it should be set to private. And a serverless function either sends a message to you or it fixes the permissions. For something like this, it's excellent because you're not paying for a virtual machine to be running, and you just pay every time you need to fix a problem, which is great. But what if that problem happens all day, every day? It may be far, far cheaper to put the application on a virtual machine. So when we talk about serverless and you think about cost, I'd like you to think about taking a taxi versus buying your own car. If you live where I live in Florida and everything is 10 miles away, and I had to go to 4 places per day, and that would be 4 10-mile round trips each day, it probably wouldn't make sense to pay $200 a day for taxis. Probably not. But where I live, it would probably make sense to buy a car, even if it's $1,000 a month, and pay the $1,000 a month for the car by the time you're all in with your car costs, your fuel, your repairs. It might be cheaper to pay $1,000 a month for the car than it might be to pay $200 all day, every single day of the month, which would be $6,000 versus $1,000. Likewise, if I'm in New York City and I can walk everywhere, but I only need to take a taxi twice a month, it's probably cheaper to take the taxi than it actually is to go out there and buy a car and figure out how to park the car. So same thing with serverless. And that's why you'll find companies like Amazon that went all serverless for Amazon Prime, realized it was way too expensive, and they came off of serverless and went back to the old-fashioned monolith. You'll find other companies that are on a monolith that probably could go to serverless, but it's based upon the way they use the data. So make sure you don't ever recommend any technology without understanding the point and the purpose. So now we're going to talk about AWS Lambda. And AWS Lambda is a serverless computing service that lets you run code without thinking about the servers or managing the servers. I'm going to make it very clear right now that it still runs on a server. So it's not exactly serverless. You don't think of the serverless. So kind of keep that in the back of your mind. So AWS Lambda will help typically with event-driven architectures. If this happens, do this. It's a good way for businesses to leverage some form of automation across their infrastructure. And that is something pretty great. So I always looked at it this way, is basically you take the code that the developer wrote, they push it and upload it to the Lambda function, and it runs when it's needed, and each time you use it, you pay. So the less you use it, the less you pay. If you use it too much, it's going to get real expensive real fast. So some things to know about Lambda is stateless. So what does this mean? It means that as soon as the function is performed, and as soon as that code's run, that's it. So if you need to have a step 1 and a step 2 and a step 3 and a step 4, you're going to need 4 different Lambda functions, and they'll all need to be scheduled in a way that's going to work. So Lambda is going to be very useful along with an Azure function, along with a function as a service on some of the various private clouds, because it can be fairly efficient, because we can use it to decrease things that require manual intervention, thus enhancing productivity of our staff. We can use Lambda sometimes to help us process data across multiple systems, remediate security events, patch an operating system. So lots of things that we do as people, we can run with a Lambda function. So very common use case is somebody puts something into S3 and it does something. So let's say I had a video editing business here, and I'll draw it out for you, but let's say I was in the video editing business, and maybe I made commercial movies or edited videos for another company. I could have the user upload their video, right? And they're going to upload it into, say, object storage, otherwise known as AWS S3. I can immediately have a Lambda function kick it off to be transcribed from Amazon Transcribe, which we'll talk about when we get into the AI section of this course. I could have that same video sent to a video server. The video server could take my uncompressed video, which could be, 5 terabytes of it, and it could potentially turn it into a web-optimized MP4 video, using, say, an H.264 and H.265 codec. And I can even have another Lambda function kick off a notification that says, Mike, your video is ready. So that's where we use these kind of Lambda functions to kind of automate things. So Lambda is basically in your entire system. Now, there is also the option to run Lambda at the edge of your network. So as soon as somebody hits your content delivery network, assuming you're using CloudFront, you can run one of these little mini Lambda functions. So by doing so, it's going to be out closer to the user, which will mean lower latency and higher performance, should this need to occur. So when we think of Lambda, some things to think about is that it's serverless. It's running on servers, but Amazon manages the servers for you. So patching the servers, scaling the servers, etc. So you don't have to think about the need to provision or manage your infrastructure, but they do it for you. Anytime somebody does something for you, they lose control. You lose control. So lots of times event-driven, lots of things you can do here. You can have a lot of event sources, something in object storage, maybe something in DynamoDB if you were using it, something in Kinesis, SNS, SQS, API gateways. So lots of ways you can integrate this into other things. And, it runs many programming languages. So if your developers code something in Node.js or Python or Java or Ruby or C# or Go or any of these custom runtimes, you can upload that. The Lambda functions will understand it. So you can bring your preferred language, or I should say your developers could write their preferred language. So because generally speaking, these Lambda functions can just grow and scale, if you need to use it a lot, it will tend to scale, which is great. So it can handle thousands of concurrent running or executions, if you will. But you got to remember, each time that thing runs, you're getting charged for it. So is it the right way? That only the people that are designing the system, that understand the system needs, can determine if this kind of Lambda thing is a good thing, a bad thing, or somewhere in between. So one of the features of Lambda is resource management. It gives you the ability to allocate a certain amount of memory and control the execution time per function, how fast it needs to occur. And the charge every time is based on how long it runs and how many times it runs. So think about that. From a security perspective, an IAM is only a small component of security. There's many more things that go into security, but Lambda is well integrated into the AWS Identity and Access Management system. So it enables you to take care of that through the systems you have which most likely will be Microsoft Active Directory federated into AWS Identity and Access Management. So there's some new features. For an example, now .NET 8.0 runtime actually runs with Lambda functions. Ruby 3.3 is now actually available. And there's also some new integration tools that are there. Some enhancements that can get into the AWS serverless application model. There's an AWS toolkit for Visual Studio. So they're trying to make it easier to develop, deploy, and manage these Lambda functions, especially with .NET. So I had mentioned real-time file processing would be a use case we would use. We could use a Lambda function to kick off an ETL system where basically we extract, transform, and load something from one system into another. Typically, you might do something like that with like a Kinesis string on the way to, say, a DynamoDB or something like that, or an Apache Kafka on the way into, say, an Apache Cassandra, which would be more optimized for multiple cloud providers. We can use Lambda functions as the back-end logic for a web application through an API gateway, and it can handle authentication, authorization, and other back-end services. We can use Lambda functions with our Internet of Things devices, like an IP-enabled refrigerator, your IP-enabled TV, a weather sensor, those kind of things, or IoT devices. So again, we can process data from those devices with Lambda, filter it, trigger alerts, that kind of thing. But really, it's for automation. So how do we set these things up? Well, we go to create the Lambda function. So we're going to go to the management console, navigate to Lambda, and click Create Function. Then we'll choose an authoring method. Either basically write one from scratch, basically, your developers write it, or in many cases, there's actually a blueprint or a serverless application repository that you can pull from. You'll configure your function settings like the name, the runtime, and the role. Then the developers will write and upload the code, write the code, and you'll upload it. And it can be written in, let's say, an inline editor, or uploaded as a zip file that will contain all the code and the dependencies. You can store that code in an S3 bucket and store it and upload it from there. Then you have to configure the triggers. The Lambda function will run inside when what occurs. So what causes it to kick it off? So you have to configure the triggers. Maybe it's something in object storage like S3. Maybe it's something in DynamoDB. Maybe something hit an API gateway and you want it to respond instead of that. Then you'll set your necessary permissions to make sure it actually runs. And then like anything else, you test it. You just don't deploy it. You test it and make sure that it works and functions as designed, and ideally stress test it before you put it out there. And then you just monitor the system. And you look for things like how often it's running and is it the right thing to still do? How long does it run? Is it running right? What are the error rates? And are things getting throttled because we're coming in too hot and we can't handle them? So we should be able to look at this, look at the logs, and make better decisions based upon it. Now, when it comes to these serverless applications, they don't perform, generally speaking, as well as a monolith when they're not running. Because a monolith is always running. You got something on a server, it's always running. These serverless components, basically, unless they're running, they have to start. So there's a cold start time. So there's a latency in these things. They don't feel or perform as well as an older school application would be because they're not running all the time. Now, it's a strength that it's not running all the time if you don't use it a lot because it's cheaper. But if it runs all the time, it's more expensive. So you got to think about this. But can you tolerate the latency in this application? Now, how do you minimize the performance hit you get with these Lambda functions to make them feel closer to normal? Well, you can keep your function packages small and the dependencies minimal, and that'll reduce the cold start latency. You can use, say, provision concurrency for functions where you need predictable traffic, and that way you're going to have the resources you need when you need it, so it'll perform better. Some other best practices with regards to Lambda are making sure you've got some kind of error handling and retry logic built right in. You can try catch blocks and implement retries, the kind they use this exponential backoff or transient errors, so they don't all try at the same time. You may want to configure a dead letter queue to analyze any things that were failed and even capture that information, just like you might do in a database. You're going to want to monitor these things and monitor them very closely because they can get real expensive real fast or be perfect. So you have to monitor the invocation metrics, optimize the function time so it runs in less time to make it less costly. They say you can use AWS Explorer to analyze your costs and usage patterns, and you can to a degree, but you're also going to have to do the planning and really to know what you need and analyze it and really think about it architecturally. So that's the end of our Lambda functions. Let's briefly talk about some data warehouse stuff. And then after the data warehouse stuff, what we'll do is we'll take a break and answer some questions. A data warehouse is going to be used in the big data environment. And it's really a database of some kind. But it's going to be a centralized repository that's designed to store, manage, and analyze huge, ginormous amounts of data. Structured data, semi-structured data, and coming in from all kinds of sources. They enable businesses to really perform these complex queries, generate reports, and derive insights from their data. So if you've got good data, you can understand the business better. You can make better business predictions like how much stuff we need, potential do we need inventory, what's our time to manufacture, what are our customers looking for, what are their buying patterns, what's the sentiment with the customer products, how do we price their system, all that a business decision has to do. They need to make informed business decisions. Better the information, the better those decisions are. Better the information, the less mistakes. The more the mistakes they have, and as part of the process sometimes, the more cost they're going to have and potentially can lose money or even go out of business. So good information is absolutely critical. Typically speaking, and I've drawn a proprietary environment here. I wouldn't necessarily recommend this in life, but keeping it in theme with just an AWS Solutions Architect Associate, you see what I can do here. I can take information on my object storage buckets. I could take it from databases. I could take it from anything, and there's typically some form of a mapping and reduction process which basically normalizes the data. Typically it's via PySpark. Amazon has their own managed service to do it. They call it Elastic MapReduce. And what they do is you take that information and it gets popped into the database, and Amazon Redshift is their version of a data warehouse. There's other options like Postgres that you could use or other commercial data warehouses. And then Amazon QuickSight is a visualization tool. People tend to use Power BI and tools like this because they can use it across all their clouds. But the point is you're going to look at that big data warehouse and you're going to be able to visualize your data, look at it, analyze it, use it in the future with machine learning or other things as well. So that's what you're actually talking about. So let's talk about some key concepts in data warehousing. One of the things that often has to happen is businesses have a lot of different kinds of databases. They'll have the relational databases, their NoSQL databases. They may have some graph databases, which are forms of NoSQL data. They're going to have a lot of different databases. Data warehousing databases. You walk into some enterprises, they could have 50, 100 different databases or more. So lots of databases. Now, when we get the information out of the databases, we need to make sure that it fits and it's cleaned up and then it can go work in another database. And, there's two kinds of things we'll do. We're doing some mapping and reduction, which is like taking Mike Gibbs. Mike Gibbs could be spelled with all capital letters. Then I could have Mike Gibbs spelled with all lowercase letters. Then we could have a Mike Gibbs with a capital M and then lowercase IKE, and then a capital G and a lowercase IBBS. And, mapping and reduction, we've got to normalize that so it's all the same Mike Gibbs, because we don't want three different records for the same person. This extraction, translation, and loading is how do I go out of MySQL into Postgres, or how do I get out of MySQL into Oracle or something like that, or in and out of databases and in and out of anything. So we're going to be dealing with a lot of extraction, translation, and loading tools. And maybe we pull data out of a database, a flat file, an API, and these tools are going to help us do this and then potentially clean the data, transform the data, and then load it into another system. So under the transformation these systems do, we're talking about cleaning the data, aggregating the data, and formatting the data. Now, the loading is taking the transformed data and sticking it into the data warehouse. Some key things to think about when it comes to data warehouses are this online analytical processing. And that's going to be a category of data processing that's going to enable these complex queries so you can perform some fairly significant analysis. basically going through a lot of data from a whole lot of different sources. They're also here with regards to online transaction processing, and that's going to focus on managing transaction-oriented applications and real-time data processing. So there's lots of applications that are transaction, like when you purchase something, when you buy or sell a stock, that kind of thing. Now let's talk about schema design. The logical structure of a data warehouse is going to be often organized in, say, a star matter or a snowflake schema. And star schemas are basically a central fact table that's going to be connected to a bunch of dimension tables. And the snowflake schema is going to be an extension of the star schema where the dimension tables are going to be normalized into multiple related tables. So we're not all data warehouse experts, and a lot of this is way above what's needed to be known, but just thought we'd give it to you for some extra background. When it comes to the data warehouse, we've got to get our data from somewhere, right? So we're going to have various sources of data, like databases, flat files. It's going to be coming from everywhere. And, sometimes we need a staging area. So we may have to clean up the data and pop it somewhere before we load it into the data warehouse. But at the end of the day, the core of the data warehouse is going to be the storage, which means if you're on the cloud, for the most part, it's going to be block storage. In a data center, it could be file storage or block storage. Now, one of the things when we're dealing with data and big data, and we'll be using a tremendous amount of object storage in these big data environments, especially with regards to data lakes, is the more information we have about the data, the easier it is to work with the data. So ideally, there's some metadata here, which may identify your schema definitions, where the data comes from, like the data lineage, if you will, and your business roles. Of course, we're going to need query tools, which are going to be the interfaces used to query the information, to get the data. And we typically need tools to be able to visualize the data, like Power BI. Now, businesses have a lot of data, and they're usually located in 1,000,001 places. But with a data warehouse, it gives us the ability to centralize it in one place, into a single repository. And it helps us enhance our data quality. Because we have to standardize and clean the data, it's going to ensure some consistency and accuracy of our data. And data warehouses are designed to deal with read-heavy operations. Because what are you going to be doing? You're going to be pulling. The whole plan of getting the stuff in there is gradually put it in there and then pull it out when you need it. It's going to give you great historical data analysis. Think trend analysis and forecasting from a business perspective. And these things typically scale to handle very large volumes of data. And that's why it's a data warehouse. Now, data or anything else, we really should have a good governance policy. So an organization will need to establish policies and procedures for data management because they want to ensure the quality of the data and the security of the data. And of course, under best practices, we have to think about scalability planning. We can't just design it for today. We have to design it for the future and as things change over time. Now, these things are going to get big. So we're going to have to optimize the performance somehow. So whether we use indexing, partitioning, or any other techniques, which we talked about to enhance query performance, that's an option. Robust security measures. You probably should have good security on your database. Make sure that you know who can access the system. You should have some good network filtering so only the right people can access the system. Probably should encrypt your data. You should be auditing these systems from time to time to make sure that they do what they're supposed to. We're going to maintain these systems, some routine maintenance tasks. Things like data archiving, data cleanup, and data optimization we're typically going to be involved with. So where are we going to use this? Well, we're going to use these data warehouses for business intelligence, meaning making data-driven decisions through a report or a dashboard and being able to look at what we've seen in the past. Customer analytics. So you may want to find out what your customer's buying behavior is, what their preferences are. If you know what your customers like, you know which products not to stock and which products do stock for them, or how to make recommendations for them to purchase additional products. Kind of like if you go to the restaurant and you'd say, I'd like a cheeseburger, they would like to say, would you like fries with that? No, I don't want fries. I'd like broccoli instead. Although my wife likes fries and lots of people like fries, but they try to upsell you into something else. That's really what we're talking about here. Financial reporting. There's so much data out there, and many businesses need to file financial reports. I mean, everybody has to file some form of financial report, every company or person at the end of the year with the tax authority in most cases. But big businesses, they've got to file all kinds of SEC things, and it needs data, and more data. So this can help with that. How about business operations? Sometimes you don't know whether their business is working well or not until you start looking at it. And because we can perform deep analysis, we can get some information about the health of the business and make changes as necessary. Supply chain management. We can analyze the supply chain, figuring out who's getting us what we need, when we need it. Is it coming in too expensive? Is inventory spoiling? And we can optimize that because the supply chain is really critical for business. So that's a data warehouse. And what I'm going to do is I'm going to stop there and take questions. And then afterwards, we'll talk about various data warehouse options. But I wanted to at least make sure everybody knew what a data warehouse was before we talk about, hey, let's talk about AWS Redshift. Because if you don't know what it is or how these things work, it doesn't even matter if you know the name of the brand these people are at. So bring us your questions. If you have any questions related to the content, please let us know. And we'll take them for a few minutes. And while we're waiting for us to see, if you're having a good time, please hit the like button, subscribe to the channel, and hit the bell to be notified of new videos to help you in your career. And if you've not downloaded the labs or at least signed up for the labs, please do so. Hi, Mike. AWS has a run command. Can the AWS turn on equipment? So, yes, AWS does have a run command, and that can turn on an instance. But remember, these servers are running 24 hours a day, 7 days a week. It's just they're all running, and the software enables you to turn or turn off that virtual machine or that virtual thing. So not going to turn on your physical equipment as a rule, but it can definitely do your virtual equipment. What kind of precaution would you have taken to avoid the issue of the outage today? So, well, first, we need to completely understand the issue, and we don't completely understand. But I'll give you some examples in high availability situations. Generally speaking, no single points of failure, but here's what goes into high availability. First, no single points of failure, which means redundancy everywhere. Very good change control processes. Very good change control processes. And testing, and more testing. So, generally speaking, and here's one of the differences between people that know how to design a 5 nines network, and people that say they don't, is it takes 6 to 12 months to design an architecture. And part of that is designing what the needs are, and the current technology, and future technology, etc. But it also means looking at the business. So, when I was designing systems for banks, specifically the trading floor, we made sure that the trader to the left of me and the trader to the right of me were plugged into different switches. And they were on different subnets. And why did we do that? Because if one of the switches failed, the trader on the left would go down, but the trader on the right could process that user's trades and vice versa. So, in generally speaking, having a single pane of cloud in most cases is reckless for high availability systems like a bank or an airline. But more than one cloud wouldn't have solved today's problem, because today wasn't a cloud failure problem. So we have to test the information that we put on our systems, and we also have to we have to determine what applications we're going to allow to access our kernel level or get high up in our applications. Today's issue is a lot of people went to a security provider that was able to push new things which could brick or damage people's computers. Now, the question is, architecturally, should that have been allowed? Well, there are some advantage of having security providers do what they did in this particular case where they can push stuff to your systems, zero-day attack prevention. But the architectural trade-off is by doing that right then and there, they're pushing stuff on your system, which isn't tested on your system yet, which is considered reckless in most high availability environments. So there's a couple of things. One is they could have chosen a security option where it didn't automatically push the stuff out there. That would be one way. Another way would have been put 50% of your users on CrowdStrike and the other 50% of your users on something else. And that way, if CrowdStrike had an issue, the other company would do it. But if they thought about it and didn't let the systems just push that to their systems ahead of time, they would have had a harder zero-day approach should an attack occur that they didn't know. But let's be fair. We can look at an environment where they could have had 2 and 3 different next-generation firewalls. Typically speaking, there's a lot that could be done with regards to network security that people don't do. So there's a lot of pieces and places and tools where we can actually design our security. Now, I don't have a full understanding of exactly what happened today because I'm not there. And a lot of times where we're getting explanations, they don't sound completely real or completely comfortable. And I hope my power doesn't go out. It sounds like there's a hurricane outside. But there is that. But that would have been something that could have worked. And that's something we did when we traded with traders and the training floors. We could have done this. They could have potentially had Windows user, Mac user next to each other, or Windows user, Linux user.
Right, everybody. So looks like we lost Mike there as soon as that thunder hit. Sorry, you do not get me with a camera today. I am working from home, not in the office, without my camera set up. So Mike is going to be reconnecting to his battery backup here and connecting to his backup internet as well. So hopefully you guys do not mind having a blank screen talking to you for a few moments. But please feel free to put in any questions that you might have, and we will get to them when Mike returns. So let's see if I can take this question down. All right. All right. Mike is absolutely safe. Just waiting for him to reconnect here. All right. All right. Well, in the meantime, let's see here. Okay, so in the meantime here, let me know what day has been your favorite, or what subject has been your favorite so far. Let me know in the chat box. I always like to know what everybody's liking about these boot camps. I'm glad to hear that you're loving the teaching style. That's one of the things that we really try to differentiate ourselves with, is the way that we teach this. We don't just teach the technology of what it is and how to use it, but we actually try to teach about the actual understanding of the technology. So Amos, let me find the link for the book here for you. So let's see here. Got there's the link to the exam guide. I'm also going to put the link to the lab demos here as well. Mark's favorite is the Q&A portion. Let's see here. We got Adrian's is the virtual machines, containers, and Kubernetes portion. Good good section there. Ben likes that it goes into a lot of depth on each topic. Absolutely. That's exactly what we try to do here. Ben still needs to brush up on Kubernetes. Well, definitely rewatch the content there. And then you know where to get the best information about Kubernetes? Kubernetes. So let me bring Mike back in here. There is Mike. All right.
I am so sorry about that. I am happy to be back. You've got a power outage, and unfortunately, the UPSs in my house aren't necessarily as strong as I need to for some of the things. I'm actually on my third internet connection right now. Hopefully, my video looks okay because it's my backup to my backup to my backup. If we need to, we'll go back to my primary connection. So let's have some fun. So anyway, we were talking about eliminating single points of failure, not putting all your eggs in a single basket. So instead of buying one stock, you buy two. And when it comes to, multi-cloud, it's not more expensive. When it comes to multi-vendors, it's not more expensive. Because imagine you had to buy 1,000 eggs. If you bought 500 eggs from one supermarket and 500 eggs from the other supermarket, it's not, generally speaking, almost the same price as if you bought 1,000 from the same supermarket. So I know we got cut off on when we're discussing high availability, but architecture designed for the client and the client's needs and goals. Understand the business, understand the challenges, understand the pain points, and really game these situations ahead of time. What happens if this fails? What happens if this fails? What happens if this fails? What happens if that fails? And then test it. And then you'll find out where your weaknesses are. But I am back now, and hopefully the weather will hold, because I love doing these kind of things, and thank you so much for waiting for us. So, Chris, was there any other questions? Otherwise, I will get back to the... Okay. Can I explain the use of data warehouse tiers from an architect point of view? So, I don't have a lot of expertise in that, and I don't want to really misguide you. It's a great question you had, George. And one of the things is, typically when I build my team, I bring both a big data architect, I bring a database person, and I also typically have some data scientists in my architecture. But I actually haven't really covered that much of some of the data warehouses that we're going to be using yet. We've got other content we're going to talk about. Who configures Lambda to do with the automation? It's the cloud engineer, James. So cloud architect designs the solution. Cloud engineers build the solution. Potentially DevOps engineers will build the solution. Once it's built, it will go to a team of maintenance people that are called sysops. And when it breaks, it's going to go to the tech support team in the business. So these jobs are highly specialized. And why do I say this? Because a lot of time people want to become cloud architects, and then they learn how to build it. And that's great, go learn how to build it. But learning how to build a building won't teach you how to design that building. And that's why they don't hire the construction people, generally speaking, to be architects. So this is usually done by the cloud engineer. But to be fair, the cloud engineer is most likely going to be, James, taking the code that is written by a software developer. And it's not going to be uncommon to have a developer or a DevOps engineer actually upload their own code too, because this is really, really simple. So there's that. And the reality is, no matter where it's at, it's going to take a collaboration. Cloud engineer is the fixer, the builder. Go in there and go do it, right? But they're not a software developer. A cloud engineer may write a little code like an automation script, like a Python script or a Bash shell script or a Windows PowerShell script. But they're not software engineers. You're going to go to that software engineer to write these things if it's an application. And who's going to design that application? That's going to be an application architect, who will then go to a cloud architect that kind of oversees everything, because the cloud is the network, the data center, all the compute, all the storage, all the data, it's everything. So I kind of hope that makes sense. If I answered your question, great. If not, please feel free to ask it again, and I'll take care of it next time, because that's an important question. All right, so now let's go back into more of this data warehouse content. So the next one we're going to talk about is Amazon Redshift. And if you're just on AWS and you're not using any other clouds, or you want your data warehouse to be on AWS, this is where you're going to put it. And Amazon Redshift is going to be a fully managed petabyte scale data warehouse. And it's based on Postgres SQL. You could just use Postgres SQL on as many clouds as you needed, but it's based on Postgres SQL. So it enables you, the user, to perform SQL queries, that sort of thing. And it works with applications that tend to perform SQL queries. So let's talk about it from a scalability perspective. It's going to scale really well. You know, Redshift is based on Postgres. Amazon manages it for you, which is a convenience, but you know, there's the challenges with being managed by someone else. Just like the CrowdStrike thing today, if it's managed by them and you don't have insight into what they're doing and they push something to you, you're at the mercy of the provider themselves. So think about that when it comes to managed services versus managing your own. And think about who's a higher target, statistically speaking, for a hacker. A big provider or you. Hack the big provider, get access to the customers. Hack you, only access to your data. So all these things to think about. So when it comes to scalability, these things really give you what you need. So think about that. You can start small, and it can progressively grow as the business's data grows. Tends to perform wise because it's designed to be a data warehouse. It's optimized for high performance storage. Redshift uses columnar storage. It uses data compression and parallel processing, so you get good responses to your queries. Because it's a fully managed system, Amazon Redshift is going to be easy to use because they handle the setup, the operation, and the scaling of the data warehouse. Now, you lose control, but you can also focus on your more of the business. So there's ups and downs of everything. It's just, architecture is just a process of trade. So let's talk about the architecture of Amazon Redshift. Well, it's based upon clusters for the most part. And the warehouse itself is going to be considered a cluster. And the cluster is going to be based on one or more nodes. And you're going to have a leader node and you're going to have a compute node. So the leader node is going to manage the connections and receive the queries. And it'll pass the queries on and develops the execution plans. Now, where's the work done? Well, the work is done on the compute nodes. And it's sent back to the leader node. Are we seeing this pattern? We have in anything else, we've got a routing protocol that determines how the path goes, called the control plane, and then we've got a forwarding plane that does the work. In container orchestration, we've got an orchestration platform. And then you've got a work platform, control plane, data plane. In this environment, you got a leader node that's kind of the control. The compute node is the plane. You go to the cloud provider, the management console you go to, all that stuff that you're feeding into that's orchestrating stuff that's going on, is the control plane. The worker plane or the data plane are all the servers and storage that Amazon has. So I hope you're starting to see these patterns. Almost everything is almost the same. It's just how you look at it and understand it. So when it comes down, and that's why if your fundamentals are good, you'll understand new things very easily. So when it comes down to Redshift, there's different kinds of nodes. There's what's called dense storage nodes, and they're designed to handle a lot of storage. And there's called dense compute nodes, and they're designed to have lots of CPU and memory resources to do the compute. And there's also something called an RA3 node, and that's going to provide the capability to decouple your compute and storage costs to enable more optimization. So instead of just trying to scale everything at the same time, you can figure out what you need and do it as needed. So let's talk about loading data in to Amazon Redshift, because it's a data warehouse. It does us no good if the data is not there. So the data can be loaded into Redshift from various sources, such as Amazon S3, DynamoDB, RDS, or any other commercial databases you could load stuff into it. You can use the AWS Data Pipeline, the AWS Glue, or a commercial extraction translation loading tool, or a self-organization makes their own script. Whatever, it's going to work. It's going to support the copy command to efficiently load data from, say, any of the AWS sources like S3, DynamoDB. and it can handle lots of files in parallel, so it's going to load relatively quickly. Now, remember, Redshift uses is based upon Postgres, and Postgres SQL is a relational database. So you can run SQL queries on Amazon Redshift just like you could Postgres. And it also enables you to do some advanced query optimization, so there's techniques that you can use. Predicate pushdown, late materialization, data skipping, and these are tools that you can use to optimize your query for those people that would need to do that in their jobs. Materialized views will basically store pre-computed resources of queries, and that's going to really speed up frequently accessed queries. So let's talk about some best practices. Data distribution. You should use appropriate data distribution keys to ensure that data is evenly distributed across nodes, and that's going to optimize your query performance. The use of sort keys to improve query performance, and this is going to be very beneficial if you're using a very large data set. Compression is something that can also help here. You may want to enable compression to reduce your storage costs and potentially improve your input-output operations performance. Concurrency scaling. We can set it up to automatically add capacity to handle spikes in your queries, and that way you're going to have somewhat consistent performance. And it's database, so maintain it. Regularly analyze and vacuum tables to reclaim storage space and optimize performance. Redshift, where you're going to use it the same place you would use it like in any other data warehouse. Business intelligence to make better business decisions with potentially a tool like Power BI or Amazon QuickSight. You could be looking at huge logs and trying to gain some insights for your logs, although it might make more sense to use a SIEM system in today's world. We can use this, Amazon Redshift, to integrate into, say, a data lake. And potentially, if we can integrate it with S3, it makes it very easy to run queries to provide a data analysis on it. Customer analytics. We can ask, again, just like any data warehouse, customer buying patterns, preferences, and trends to come up with, say, maybe sales or marketing strategies. So how do you set this up? Or how does the engineer that builds this set this up, I should say? You can go to the Management Console CLR API and just create a Redshift cluster. You're going to load your data. So you're going to use the copy command to load data from S3, DynamoDB, or other sources. You're going to run your queries and ideally connect your business intelligence tools to it so you can see what's going on. Like any other system, you'll monitor it, you'll optimize it, and you'll look at what's going on. Because it's an AWS thing, you can look in CloudWatch, but also use other tools to monitor the performance of your databases. So that's about data warehouses. So next we're going to talk about data lakes. So data lakes are kind of cool. And in the machine learning environment, they're becoming very popular along with databases and other forms of big data, but they also are there to really enable the organization to do some pretty cool things. So the data lake is going to be a centralized repository that's going to allow you to store all of your structured and unstructured data together at any scale. So as much stuff as you can possibly imagine. Petabytes of data. Now you'll be able to store the data as is. And that's different than, say, in a database where you got to make it look a certain way before you put it there. And it's going to enable, as we get talk more about this, visualization, large-scale analytics, artificial intelligence, machine learning, because we're going to have a good source of data if we build it right. So I like to think of it as a repository. That's where my data goes. Raw data. So let's talk about the differences of other options here. Unlike a database, a data lake can store anything. Structured, semi-structured, unstructured. With databases, we talked about, read replicas and caching and queuing and other things for relational databases. We talked about partitioning and other options for NoSQL databases. We also talked about partitioning for our relational databases too, but they're not going to go to petabytes, most databases. This stuff is petabytes of data and beyond, so big amount of data. Data lakes, unlike a database, are extremely flexible. You can invest lots of data natively, simply, and easily, and either use it now or use it in the future. They tend to be cost effective. I mean, If you consider cloud object storage to be cost effective, you could call it cost effective, but here's the key. You're putting in object storage, it's got metadata on it, and it's going to be cheaper than other forms of storage you might use, like block storage. And it's the concept of schema on read. So the data is going to be stored in raw form, and a schema can be applied when the data is read. So you can put it in easily and then pull information out a lot in a more sophisticated manner. So how do you build this thing? How do you design this thing? Well, the first part is we've got to get the data into the data lake. And this could be via a batch processing manner. It could be streaming data, like coming in from, say, an Apache Kafka. It could be real-time data ingestion. But we've got to get it. So the first part is getting the data or ingesting the data. No. After we ingest the data, we got to store it somewhere, right? So raw data is going to be stored in a scalable storage, and that's typically going to be object storage. Object storage scales, and object storage has metadata, so it's usually going to be object storage. The next thing is that data needs to be cataloged, and it needs to be indexed. So the metadata is going to be created to catalog and index the data, and that's going to make the data more easy to discover and understand. And then somewhere along the line, we need to process the data. So data processing is typically done with something like a PySpark, an Apache Spark, Hadoop MapReduce, that kind of thing. And then there's the analysis and consumption. So we've got all this data. Now we can run machine learning on this data. We could use a business intelligence tool on this data. We can run an SQL query on the data. So let's talk about what goes into it. I'll summarize. Ingestion. We got to get it. So it could be batch processing, streaming, a REST API, real-time data ingestion like Kafka. Then we store it. Then we catalog it and index it. Then we process it with a big data framework like typically Apache Spark or Hadoop MapReduce. There's some mapping and reduction, which is typically done via something like a PySpark. We analyze the data and make some decisions on the data. So that's basically where they're at. So where would we use this? Let's talk about some use cases for data lakes. So big data analytics. Businesses have a tremendous amount of data and things that they can analyze that data and make better business decisions. Machine learning or any kind of artificial intelligence. The better and more accurate the data is that a machine learning model is trained with, the better the outcomes will. Garbage in your generative AI models data, garbage out. Quality data in, impressive things out. So, machine learning. Data archival. Maybe we just want to stick all the data we have in some place and figure out maybe we want to use it later. Let's think about getting data from all kinds of wacky things, like Internet of Things devices. And we might use it as a staging area to maybe either extract, transform, and load from one system to another. Or we might extract, load it, and then transform it into another system with an ELT process. So, there's lots of tools we can use. But the key here is centralized data, better analytics, enhanced accessibility of data. Here is an example of a AWS 100% proprietary kind of data lake. There's much more that goes into it like this, but this is kind of, I think it'll help. You take the data out of your databases, like your NoSQL database, which is DynamoDB in this case, your relational database, which is our Amazon RDS, your data warehouse, your Redshift. We pull that data out, some kind of mapping and reduction function like a PySpark script. We pop that into object storage, and we'll have to do a few things in object storage, like we'll have to catalog the data and create a landing zone, typically speaking. But something like this is basically what goes into building a data lake. Coming from multiple sources, data is smoothed out, manipulated, and normalized along the way. Indexed, cataloged, that sort of thing. And then poof, you got a data lake. And then you can do lots of cool things with it, like run machine learning tools, etc. So let's talk about some challenges with the data lakes. Because when it comes to tech, nothing is free. Everything's got its trade-offs, complexities, and it's about, is it right for you or your organization? Data governance. We're going to have all this data. We're going to need somebody to ensure data quality, the data's security, and that the data is in compliance. You don't want to just take like a hospital's data, stick it in object storage, and have the person's personally identifiable information in there. That could land you in a lot of trouble. So it's a matter of what you're doing with the storage. You don't want to create what's called a data swamp. And if you're not careful and you stick all this data in a place, because the people that are designing it don't understand data and data architecture, and that's why data architects are a specialty that a cloud architect would use on their team. The cloud architect would design anything and they would ask the data architect for the data piece because this is such a specialty. But if it's designed wrong, you get what's called the data swamp, where you can't find anything. Anybody have a junk drawer like that where you just throw stuff in a drawer because you don't have any time? If you know what I mean, give me a hashtag drunk drawer, where you got one drawer where you throw your pens and a pencil and this little thing and that little doodad, and the next thing you realize you want to go for something and you know it's in there, but you can't find it. So think of data swamp as a junk drawer. At least that's how I always saw it in my head. So let's talk about complexity. Managing and maintaining a data lake, like anything else, can be complex. So it's going to require good, skilled people. I love it. Junk room, as Chris said. Yeah, I know what that's like too. And then performance. So ensuring the performance of your data processing and analysis workloads. So the next is going to be some of the technologies and things we need to think about for our data lake. And one of it is, where are we going to store it? Got lots of options. AWS S3, Azure Data Lake Storage, Google Cloud Storage, a Hadoop file system. Where are we going to process it? Apache Spark, Hadoop, Presto, Apache Flink. These are places where we could be storing things. How are we going to ingest the data? Are we going to use Apache Kafka, which is going to work anywhere, any cloud, anytime? Are we going to use Apache, I want to call it NIFI. It's N-I-F-I, but, it sounds like a Greek word, NIFI. Especially if you're here, Yogos, let me know. And we could also be ingesting our data from AWS Kinesis. And from a management and governance perspective, there's other software we can think about, like Databricks or Apache Atlas or AWS Glue. So let's talk a little bit about AWS Glue. What is AWS Glue? It is a serverless technology that's going to automatically provision and scale its resources. There's a data catalog, and it's going to be a centralized repository to store metadata and make data searchable. It's going to support, say, schema, discovery, versioning, and partitioning. And it's here to automate ETL processes, where you extract, transform, and load from one system, pop it into another. That's what it's there for. It's an Amazon-managed ETL tool. So some features of Amazon Glue include something called job authoring. And basically that provides a code base using Python or Scala. And then what will happen is Glue will actually generate the code to transform the data, which you can customize. There's the concept of job scheduling. So you can schedule your jobs to run on a regular basis using AWS Glue schedule, or trigger it based upon events. This happens, then this happens. Amazon Glue is pretty helpful for data preparation because it offers tools for cleaning, enriching, and normalizing the data. And it enables developers an opportunity to create and test scripts interactively in their integrated development, like a development environment. It automatically will discover a schema. So it's going to look at the data and try and infer a schema and then store that in a data catalog. And of course, it's going to integrate with the AWS tools for things like monitoring, logging, and setting up alarms. This is a totally fine ETL tool. However, if you're dealing with 3 clouds, you might want to use a commercial tool that you can use in all 3 clouds. But what's the architecture? What's the business needs? So what happens is you first have this data cataloging. And what happens are these things called crawlers that literally go out there and scan your data sources. And that's where they guess your schema from. And then they populate the Glue data catalog with that metadata. So Then there's the manually defining the tables and schemas within the data catalog space. Next, the ETL job needs to be created. So the Glue is going to generate the code to run the job. Of course, you could write your own code if you wanted. And then the job's going to run, and you schedule it. Do you run it on demand when you want it? Do you want to run it every Tuesday night at 2 o'clock in the morning in a scheduled environment? Or do you want to run it every time something occurs? Something's dropped in an S3 bucket, poof, run the job. So regarding the data transformation and loading, you're going to use this to transform data, so you can apply transformations such as data cleansing, data enrichment, or normalization. And then you're going to load the data into the target system, whether that be S3 or Redshift or RDS or anything else. So where would you use Glue? Well, anytime you would use an ETL tool in the creation of a data lakes, because it would maybe catalog and transform and organize your data. A data warehouse, taking your information and sticking it in your data warehouse. Data preparation, because it's going to clean and normalize and transfer your data before you look at it with like a Power BI or an Amazon QuickType, some kind of data visualization tool. You might use an ETL tool like this for any kind of machine learning environment, because you've got to clean up your data before you use machine learning tools, whether they be things like AWS SageMaker or any other machine learning library that's out there. And any kind of data integration, because you're often going to have to integrate and transform data from lots of different databases and data stores, and in some way that's going to be clean. Chris, I think it's probably been about 20 minutes, so maybe I'll stop there, see if anybody has any questions. This is a very good question. So hi, Mike, great training. What are the fundamentals to learn? NB, it all is based upon your goal. If you give me your goal, I will happily tell you on the next break, unless you respond very quickly. The fundamentals to learn for a cloud architect are very different than the fundamentals to learn for a cloud engineer, which are very different than the fundamentals for a DevOps engineer, which are different than a network engineer, which is different than a software developer. The same way an airplane pilot and a lawyer need to know different things. So I will happily give you the fundamentals when I know which career you're actually looking for, because learning to code will not make you a better architect, because we don't code. We also don't look at code in our job. We design systems to optimize business performance, including of networks, data centers, security, all of it. So there's that. But that learning to code would be critical. Oh, so you want to be a secured cloud, security cloud, so I still don't know what you mean. Do you want to be a security architect? Do you want to be a security engineer who defends the systems? Do you want to be a what do you call it, an ethical hacker that breaks into systems? Because if anyone says, gives you any information without knowing your goals, it's going to be very dangerous. Just like designing an architecture, we need to know the business goals before we design it. So if you tell me, I would be getting honored to determine what you need to do. Security cloud architect. Okay, so I'll give you the fundamentals for that. That becomes easy. So the first thing to remember is this is a job where you have to design systems to optimize business performance. And my team is going to give you an ebook that we wrote for this. So you will need to develop your business acumen, your leadership skills, your sales skills, your executive presence, your emotional intelligence, your presentation skills, and your writing skills. If you don't have these skills, you will not be considered as an architect. So there is that. Next, what is it you really need to understand as a security architect? It's not how to set up a firewall. We don't do that. It is how to design the end-to-end security for an organization. So what does that mean? It means first understanding the organization's assets. What is it that they actually have? Is it intellectual property? Is it the formula for the new next generation GPU, a life-saving drug for cancer, for example? Because if you don't know what it is you're protecting, you don't know the type of protection you would actually need. Same way as if you were doing executive protection, you would take a dignitary like a president and you would give them a whole lot better security than you would for a person that's a CEO of a business that's got less than 50 people, because the risk is higher and you might spend $1 million a day to protect a dignitary like a prime minister, or 2 million or 5 million a day, but you wouldn't do that for the regular person. So we need to know the value of what they're protecting. We also need to know the risk of them being hit. You know, what kind of adversaries do they have out there? What's the statistic likelihood? And we need to quantify the actual assets they have and the risk that would occur, which means we need to understand the cost of downtime. We need to understand what happens to that business when certain things occur. We need to understand the brand value, because we need to quantify it into the actual number lost, and we need to quantify that as to actual the non-quantifiable things like brand and how people see that company. For example, how do people feel about CrowdStrike tomorrow versus today versus the day before? Because you can see one little security incident can have a big impact on someone's brand. I think it's too early to tell or make any decisions about anything. But the point is that's the quantify is that. And when we know what we're protecting, then we can build a business case for security. If an organization has an exposure of $100 million a year, which could be nothing for a big business, then we need a security solution that costs us less than $100 million to protect it. So first we have to know what we're protecting. Then, so that means some business acumen. After that, we need to look at the global business. What is the business goals? What is the business pain points? What is the business challenges? Where are they moving? How do these business processes work? Which is why I gave you the business things first. Now, when we know what we're trying to protect, then we need to be able to create a policy with our customers. So what do I mean by a policy? What is that overarching security policy that says this is what they do in an incident? These are the people responsible for an incident. Physical security will have this. All information shared on a wire will have this. These are how we do this. So we're going to need to help that organization create a security policy. We're also going to have to work with that organization to determine how they manage risk. Do they mitigate the risk, which is what we could do? Do they transfer the risk to an insurance company, in which case we can talk about that and we can help that with them. Then let's go, then I'm just giving you some other things to think about. We need to think about the organization's network security. Where do we place our firewalls? Where do we place our intrusion detection and intrusion prevention systems, which means you need to understand these technologies and how they work, not how to configure them. What kind of encryption in transit do we use? Do we use IPsec? What is the overhead of IPsec versus TLS? So we need to determine encryption. We need to determine how and where people will need to access inside the systems and create the right level of demilitarized zones. We need to determine what kind of storage encryption. We need to determine the type of endpoint encryption and protection. We need host-based anti-firewalls. What kind of services do we enable? So for the security architect, you're going to need to understand the network to a big degree, the data center, applications to some degree, the weaknesses and vulnerabilities that an organization has, and then how to design a plan to mitigate it. But we don't configure firewalls. We don't configure IDS systems. We're not going there in Linux doing a user ad, that kind of thing. So those are your skills. I'm going to run a webinar next week on how to become a cloud architect. And we've got lots of people that we've trained that have become cloud security architects out of that program. So I'm going to drop a link for that. And also my team will drop a link for that book. I want you to read the book. It's completely free. The webinar is free. We'll go over the architect role and you can ask us questions. We'll have a live-to-live conversation with you. You want us to mini interview and see if you're ready for a job, I'm happy to do it. So whatever we can do to help you, and it's completely free. So I just wanted you to understand that's kind of the basic skill set. Which is more outsourced between cybersecurity and cloud computing? Well, we have to understand it's not cloud security versus cloud computing. It's the role that you're in. So if I have a sales rep, I can't really outsource that sales rep. And the reason I can't outsource that sales rep, if I have a rep that's in New York City that needs to sell to global financial businesses, I can't outsource that. Because it's human, manual, person-to-person kind of thing, based on entertaining clients, taking people to dinner, that sort of thing. So kind of keep that in the back of your mind. So a security architect is very hard to outsource, because since a real architect isn't doing any configuring, and they're meeting with clients, and they're talking to people, and they're building relationships, you can't outsource that job very easily. Now, there's still a remote work from home architects, but and that's fine, but it's still harder to outsource an architect job. Now, a cloud engineer, that is the easiest outsourceable job in the world. If I have a choice of hiring a cloud engineer, do I care if they're in California, Cameroon, the Cayman Islands, Cambodia, Cape Town? It doesn't matter, because they're going to sit behind a desk and configure things. Now, the cloud engineering could also be done by AI, because AI can write the Terraform script, AI can write the Python script, the Bash shell script, the CLI, but AI can't do architecture because it can't meet people, it can't talk to people, it can't build the relationship. It's not going to build a business case. It's not going to take your client playing golf. It's not taking your client to dinner. So it's not either one of those things. It's the career you pick in that which determines whether it's outsourceable or not. Engineering, easily outsourceable. Architecture, impossible to outsource. Engineering, where you need to be in the same room as people because you're part of some super special team where they've got the best and brightest, and you're all in the room and you're writing on whiteboards all day long until you try it out, that is not outsourceable. Engineering of a job where I don't need to go to the office to, easily outsourceable. So kind of hope that helps. Good questions. Can I explain the sequence of the interaction between a web application and storage database? And you mean like in a typical three-tier app architecture? Absolutely. So realistically, what you're actually talking about is the following. So the way you're going to come in is the web server. That's going to present the website to you. So let's say I've got a website with Cindy the cat, my cat. And she's out there and she's got a wet hand pointing to a tuna, and we sell tuna, salmon, and other forms of cat food on the website. On that website, you got pretty pictures of the cat, you got all this text, and that's what you interact with. It's serving, say, an HTML page that you access via a web browser. That is the web server layer. Now, behind the scenes, there's a business logic that's running at the application layer. And that's going to be related to, how you buy the stuff, where the stuff is in our systems, who are you, what you're allowed to do. And that's going to be what you're actually talking about, is going to be at the application layer. So you come in, you go to buy something, you get sent into that application layer, and then the purchase goes through. I bought, say, 20 pounds of tuna from the specialty Cindy the Cat Tuna web store for my cat Cindy, and it gets stored in a database that stores the structure later. So realistically speaking, that's what's going on. Now, the storage, the database will obviously be a virtual machine, and that will have, say, a virtual hard drive in it or a physical hard drive, and it could be block storage hard drive or a physical hard drive. So I hope that kind of answered you. Mike, do we have similarities between AWS, Azure, Alibaba? Yep, they're all the same. Now, what if I told you can buy water at Albertsons, water at the store called Carrefour, and water at Walmart? You bought water. So all cloud computing is, Mario, is renting space in someone else's network in a data center. So you get a virtual machine in AWS, Elastic Compute Cloud. You get a virtual machine in Google, Compute Engine instance. You get a virtual machine in Microsoft, and they call it an Azure virtual machine. You go to Oracle, and they just call it a virtual machine. Same stuff. We've talked about object storage in depth. You can get object storage, and you can call it object storage from Dell EMC. AWS could call it S3. Google could call it cloud storage, and Microsoft can call it Blob. Same thing. Okay. Well, I want to know you're awake, you're alert, you're oriented. So give me a hashtag AWS SAA. And we will take it from there. And I want to actually end with this last question because it's very important. You're not going to find more opportunities on AWS. You're not going to find more opportunities on Azure. 98% of organizations are multi-cloud. It's how good you are. It's what your skills are that matters. That's the secret. How good are you? How deep can you get into the underlying infrastructure that the cloud provider has? How innovative can you be to solve business problems? That determines your opportunities. Not whether you've got a Cisco certification or a Juniper certification or an Azure certification or an AWS one. It's all the same. Okay, I know you're awake, alert, and oriented. I'm loving this. And I know where lots and lots and lots of you are from. But I'm glad you guys asked these questions, because these are the kind of questions which keep people going down the wrong path. And that's that wrong path that keeps people from getting to their end goal. So I'm thrilled you guys asked it. So let's talk about the AWS Data Pipeline. So in business, we're going to have these data pipelines, how we get data in and the things we can do with it. Businesses will build their own data pipelines, and business could use the ones that are built by the cloud providers. Each has their strengths and weaknesses and architectural trade-offs. So AWS has a way to make this easier if you use their service. And they have this service called AWS Data Pipeline. And that's going to be a service that will enable the automation, scheduling, and management of data workflows and data processing. It's designed to move and process data at scale from a whole bunch of different sources till it ultimately gets to its destination. So some features of the data pipeline are data workflow automation. That's what it's made for. So it gives you the ability to automate your data, automate the movement of the data, automate the transformation of the data. It supports relatively complex data processing workflows, and then you can schedule multiple steps and dependencies. It's fairly flexible in the way you schedule it. It allows scheduling of data processing tasks based upon the time or external triggers, and it's going to support both periodic and one-time tasks. Data transformation. So another big feature here. So it enables the transformation of the data as it's going through the pipeline. And it supports lots of different transformations, meaning, say, like an SQL query, you can run it into a custom script. You could turn it into Amazon's version of a mapping and reduction script, the Elastic MapReduce, which I'm sure we'll talk about. Data integration. And data pipeline is going to integrate with lots of different AWS services. So if you're just using AWS proprietary stuff because you're just on AWS, these proprietary enhancements make it easier. So think about that. So it's gonna help with error handling, because you can set it up and it's gonna have error handling and retry mechanisms. So not everything works the first time, something you need to retry, and this can support that as well. So fairly robust service. It actually has a graphical interface, so it makes it easier to design, configure, and manage the pipelines. You can visualize it. You can see what's dependent upon what. And it is very customizable. So where would you use data pipeline? Well, when you need to do some kind of data ingestion, and your data ingestion also needs some form of extraction, transformation, and loading, this is a great tool to use if you're going to stay in the AWS ecosystem. Otherwise, use a more industrial tool. It also works well with data migration, because it can help you take data from a lot of different stores and then move it to, say, AWS. It can also be fairly useful for backup, because you can use it as a way to constantly pull information out of your database and maybe store it to object storage. Quite good for taking all this data and putting it in one place and then creating reports from it. So aggregate your data from multiple sources, transform it, generate reports. You might want to, for example, collect sales data from all different databases, aggregate it, and use it to produce a daily sales report. So when you set up an AWS Data Pipeline, there's some things you need to think about. Pipeline definition first. So a pipeline definition is going to be how you communicate your business logic into the data pipeline. And it's going to include the following kinds of information: data sources, and you're going to need maybe the name or the location or the format of your data sources, activities or tasks that will transform your data. Obviously, there's going to be a schedule, right? The timetable and when you want to execute this data pipeline. And it's going to include some information. You'll include the resources, like what amount of computational resources do you need. You can specify any preconditions that may be met. Maybe something needs to occur before something else can be scheduled, for example. It'll provide some notifications that can alert you with a status or an update during your pipeline execution. So I like to think about it this way. From a pipeline definition perspective, the AWS Data Pipeline is going to determine the tasks, it's going to schedule them, and it's going to assign it to something called the task runner. And if the task were to fail, the pipeline will retry the task based upon the instructions you gave it. And if necessary and you specified it, it'll allocate it to another task runner. And then at some point, if your task fails repeatedly, you can configure the pipeline to notify you. So, sound anything different than anything else? In a routing protocol and a health check, it tries again, it may try again, and at some point, it just doesn't try anymore. It's the same thing. So I want you to get these similarities between one tech and another. They're all so similar. They all use the same principles. When your fundamentals are good, you'll be able to learn anything really fast. So I mentioned the pipeline, but I really want you to think about what it's going to contain. This is the business logic of the pipeline. Where's the data sources? What are the activities going on? What are the schedules? What are those preconditions? And, it can inherit properties from the parent components, and like those nested environments we talk about with IAM, it's the same kind of thing, where we define data management rules and relationships will occur through the references. One of the things we need to do is related to instances. How many actionable units are going to be created from the pipeline when it runs? And will they contain all the necessary information needed to perform the task as they need to? And this is going to be managed by the task runners. I had mentioned attempts before. So attempts are going to be, keep track of failed operations. How many times do you want to try it? And you're going to have to put in several retries if you want some robust data management, because sometimes you need something to try a few times before you determine it's failed. And if it failed, then maybe be notified so you know how to go fix it. A little bit about the task runner. The task runner is going to be an application that's going to pull the AWS Data Pipeline, and it's going to look for tasks, and it's going to perform these tasks. The default implementation provided by AWS Data Pipeline is called Task Runner. So some other thing you need to think about. When it's installed and configured, it's going to pull the data pipeline for tasks, and it's going to activate these pipelines. It's going to perform their tasks, and then it's going to report the status back to the AWS pipeline. So let's talk about data nodes. In our AWS Data Pipeline, the data node is going to define the location and type of data that's going to be used to say as an input or an output by a pipeline activity. And AWS Data Pipeline can store information in lots of places, and they're probably going to be what you would think of the usual suspects. S3, RDS, data in SQL, data in Amazon DynamoDB, data in Amazon Redshift. AWS tool stores data and enables you to get data into AWS data storage places. So I hope that kind of makes sense. I'll add a little more on preconditions. I know I mentioned it before, but a precondition is going to be a component that contains conditions. So this needs to occur and this needs to occur before this occurs. So maybe you check the data source, make sure that it exists before you try to copy it and move it over. So there are basically two kinds of preconditions. There are what's called system managed preconditions. And this is going to be run by the AWS Data Pipeline service, and it's not going to require computational resources. But there's going to be some user managed preconditions where you may need to run on a certain system or server or virtual machine before you get it to run in the pipeline. All right, so talked about some data pipelines. We talked about extraction, translation, and loading tools, specifically AWS Glue, but they all kind of work that way, where they take data from, say, one database, they extract it, they transform it, and then they load it into another system. Well, we also have to map and reduce data as well. So if we were going to create a data lake, and I know I introduced this a little earlier, we're going to be pulling the data out of the NoSQL databases and pulling the data out of the data warehouse and pulling data out of our relational databases and pulling data out of standard object storage buckets. So we've got a lot of data. We've got to normalize that data and smooth that data and make sure that the data is consistent. And that's called mapping and reducing. So lots of big tools people use like PySpark to do this, but AWS also has their own managed tool to do this. Now, if you're in a multi-cloud environment, you might want to have the same tool you use in both clouds. But if you're just in AWS, they've got a nice tool that actually does this and integrates so seamlessly and smoothly with other AWS services. And they call it Elastic MapReduce. And Elastic MapReduce is going to be an application made by Amazon that's going to be used for processing and analyzing large amounts of data. It is going to be a managed cluster, not a service, if you will, and it's designed for managing a big data framework. It is a pre-built system that will facilitate data analysis and processing without needing to basically create your own servers and manage the servers and install your mapping and reduction software on these servers. So AWS Elastic MapReduce is built on a lot of these big data tools that you would think of, like Apache Spark, Apache Hive, Apache HBase, Apache Flink, Presto, that sort of thing. And it's going to offer good performance, and it's fully managed, so we can think about it. And in cases where the organization needs custom, heavy-coded mapping and reduction function, there's a possibility that using a pre-made tool like Elastic MapReduce is cheaper. There's a possibility it's not. But that's understanding the use case, but there is a possibility it could be. And what it's really like is, we can use it from any data source. It could be, like I said, a relational database data warehouse. We take the information out of something, we put it into this mapping and reduction system, it's reduced, it's normalized, it's cleaned up, and then we have data in something that's going to look good, it's going to look clean, and it's going to look consistent. Let's talk about some key features. So it's a managed cluster. So it's going to automate what you would normally do, which would be the provisioning of these clusters. So you're not setting up, Hadoop clusters, Spark environments, and it supports the use of multiple types of instances and configurations, but it's managed. It scales, thankfully. It'll scale up, it'll scale down, based upon the processing needs. It will support temporary clusters, long-term clusters where you need these things running a long time. If you're using AWS stuff, it integrates so beautifully with other AWS stuff. So it'll iterate so nicely with object storage or S3, any of the Amazon relational databases, DynamoDB. You'll get CloudWatch information, so think about that. If you're using, say, Redshift or Amazon Athena or CloudTrail or Kinesis or any of these things, it's going to integrate so smoothly because they're all AWS proprietary things, which integrate very nicely with AWS proprietary things. It is one of the benefits and elegances of a single vendor. There's lots of downsides, but that's one of the upsides. It would also work with, say, AWS Glue for extraction, translation, and loading. So from a security perspective, it's going to, work well with AWS security things like IAM roles, encryption at rest, in transit, Kerberos authentication, that type of thing. It could integrate with AWS Lake Formation for access control as well. The Elastic MapReduce, is going to have secrets, right? Secret things that you need to do. So it's going to let you store information with AWS Secrets Manager, which we'll talk about when we get to that as well. But that's a place to store secret information in AWS. So it's got support for a lot of the big data frameworks like Hadoop or Spark or Apache HBase or Apache Flink or Presto, that kind of thing. So because of it, it's going to enable fairly custom software configurations for the users that actually need it. And we use it for data processing, realistically speaking. data analysis and machine learning, because we might want to normalize that data. Maybe we do our data analysis and machine learning with Apache Spark. There's some machine learning libraries there, or any other learning framework. The point here is we're going to smooth the data, clean the data, and then we can analyze bigger data sets with it. We may have real-time streaming data, like click streams coming from web pages or IoT devices or something like that. And this mapping and reduction with EMR can process and analyze streaming data relatively in real time, which is great. And that kind of uses like Apache Spark streaming or Apache Flink. And that will integrate with, say, Apache Kinesis, Amazon Kinesis if you wanted the AWS proprietary streaming tool, or Apache Kafka if you wanted real-time ingestion. We might use it with lots of interactive SQL queries to enable our data analysts and maybe data scientists to perform ad hoc queries and get good information. So how do we set this up? Well, how do the engineers that actually build this stuff set this up? They launch the EMR cluster. How do you do that? You go to the AWS Management Console, you navigate to the EMR section, and you create the cluster. In that cluster settings, you set up the software, the instance type, and the networking. Now, if you take these systems and you need to install any Bootstrap software, you just write a custom Bootstrap script. You'll configure your security and your access, things like your IAM roles, your VPC security groups, that kind of thing. And you're going to just submit your jobs. You'll submit your jobs using the AWS Management Console or the CLI or the API through a software development kit, or maybe a Hadoop or a Spark interface to submit your jobs. And then it'll monitor the progress. And you just monitor it, just determine what's working, and then make decisions thereafter. And then obviously with anything, we try, we test, we learn, we optimize, we fix, and we grow. So that's the whole point here. So with mapping and reduction, with Elastic Map Reduce, let's think of some other best practices. We may want to store data in like object storage for durability and cost efficiency, but we want to have some kind of good storage. We may want to use data partitioning and compression to maybe optimize our storage cost and performance. We want to make sure that when we're dealing with data, we've got, say, good encryption of data at rest and in transit. We want to make sure that we apply to the principle of least privilege. And that we monitor costs. We look at what's going on. Is this working? Is it not working? Should we use something different? So don't just turn it on and pray that it does everything you want. Manage this. Okay. So we talked about what is a data lake. We talked about today what is a data warehouse. We talked about extraction, translation, and loading, to some degree extraction, loading, and transformation. We talked about mapping and reduction. We talked about data pipelines, and we talked about data lakes. So now let's talk about AWS Lake Formation. And AWS Lake Formation is going to be a fully managed service that's going to make it easy to build and secure and manage a data lake. And we talked about a data lake, but in case you just joined, it's going to be that centralized repository that's going to enable you to store all your structured and your unstructured data at any scale in this environment. So you don't have to structure it first. You can put your data as is. You can run some analytics on it. You can visualize your data with the right tools. You can push it into machine learning for some understanding and for predictive analysis, that kind of thing. So lots of options we can do with data lakes. So the AWS Lake Formation is making it easier and removing some of that manual intervention from you. And it can take your information from AWS services like AWS S3, RDS, DynamoDB, etc., or your on-premises database. And you can use Amazon Aurora or Redshift as well, and Datastreams for ingestion compatibility. Now, part of that data lake creation is the data cataloging. Well, using AWS Lake Formation, it does a lot of that stuff for you. So it automates the data cataloging, making the data easier to access, searchable, that kind of thing. It centralizes your security management to a degree, because Now you're setting up the control policies to access these sort of things. And you're using your systems inside of AWS to do it. It's got in that it's got built-in extraction, translation, and loading. So you define the workflows, prepare your data, and it gets done for you as part of this. So it's a managed service for a data lake in every way. It tends to integrate fairly nicely with certain analytics tools and big data tools, especially the AWS ones, because it's an AWS product. It even has some blueprints on different types of data lakes. Predefined templates to create a data lake quickly. Now, using the blueprint for somebody else's business is good if you're in the exact business and everything is the same between your business and someone else's business. But no two businesses are the same. So when you use a predefined blueprint, you really need to look, is this going to work for me? And if not, is it worth creating your own? It's a trade-off. So how's it work? Realistically speaking, the data is going to be ingested. And it's going to simplify that. Then the data is going to be cataloged. Then the data is going to be transformed with the ETL tools. And then you're going to, basically speaking, determine, your IAM policies, etc., for who's allowed to access what. And you're going to access your data. And you can catalog it, transform it, analyze it, do anything you want. Okay, so where are we talking about? We'll briefly go through part of Kinesis, or maybe all of it. So we'll see how we do time-wise before we take our next break for questions. So let's talk about Amazon Kinesis. So in many organizations, we're going to have a lot of data coming in. Lots and lots of data. And imagine a world where you have access to information. And when you take in this data in real time, you can make a decision in real time. See, normally, previously, what businesses did is they took a ton of data, they stored all this data, and then years later, they analyzed it. Well, if my wife is coming home and she says, I want to buy my 580th pair of shoes right now, and I'm able to say right then and there, yes, or because if I say no, it's going to be a lethal situation. It's not going to be pretty. She loves her shoes. Everybody loves something. I've got the own things I love. But if I know to say yes right then and there, if she asked me, but she would just buy it, she'd leave super happy, come home, be very happy, probably bring home treats for our cat, gifts for me. It would be a nice thing. But if I didn't know how to react to that, and if she were to say, hey, let's get shoes, not that she would ask, but if she were, and I came back 6 months later and said, of course you can get your shoes, that wouldn't be good. So the better business decisions we can make, wait, we got a whole bunch of things buying on right now. Okay, what do? Do we add more inventory? What's going on? So we need to have sometimes better access to information in real time. And generally speaking, we're going to need some way to take in the streaming data and do something with it. Now, in 98% of organizations that use multi-cloud, which means Kinesis will work across AWS, Azure, Google, Alibaba, Dell's cloud, IBM's cloud, or any other cloud in the world or your data center. So that is your open source standard. It is Apache Kafka. And if you were just in AWS, and again, almost nobody's just in AWS, but if you were just in AWS, or only had streaming data pipelines in AWS, and you didn't want to manage your own Apache Kafka environment, and there's good reasons to do so sometimes, you would use Kinesis. And Kinesis is an Amazon proprietary, AWS managed suite of services for real-time streaming and data analytics. And it is very cool. It enables you to ingest, process, and analyze streaming data in real time. So that's the difference. Kinesis, Apache Kafka, you can pull in your data in real time and you can do something with it. Kind of like having a live conversation with your data. So I like it. So there's a couple of versions of Kinesis, and we'll talk about them. There'll be something called Kinesis Datastreams, Kinesis Data Firehose, Kinesis Data Analytics, and of course, Kinesis Video Streams. So think about real-time data, real-time processing. Now, what's very cool is this is a managed service. And it's going to scale real well. So you just simply adjust the throughput of your streams by increasing or decreasing a unit of measurement called shards. I didn't make it up. Shards are the side of the stream. You need more of them, you get more shards. So when Kinesis pulls in its data, it typically puts the data and stores it in a couple of different data centers. So it gives you some availability of your data. It typically also has a built-in error handling and retry mechanism to make sure that it works and you get what you need. And because it's AWS, it tends to integrate real smoothly with other AWS things. So smoothly with Lambda, smoothly with S3, smoothly with Redshift. So, and even if you were going to use Elasticsearch, it was smooth with that. So on AWS and only AWS, it's going to make life really elegant. But functionality-wise, it's going to be a lot like Apache Kafka. It supports security, meaning things like data encryption and at rest, which is very important. And it also integrates with your identity and access management strategy. So we'll briefly discuss each one of those. So we'll talk about Kinesis Data Streams first. That's going to be a real-time streaming service that enables you, for the most part, to build custom real-time applications. So coming in right now, looking at real-time analytics. Maybe logs are coming in and streaming in right now, and you've got some AI that's looking at those logs in real time. Maybe you've got stuff going on right now, and you've got AI looking at it and making recommendations. That's your Kinesis data stream. By comparison, next is going to be Kinesis Data Firehouse. And that's about taking your real-time streaming information and storing it somewhere. So it comes in streaming. Maybe it puts in an S3. Maybe it sticks it in Redshift. Maybe it sticks it in Elasticsearch. Maybe it puts it in Splunk. And that's going to automatically scale to match the needs. So streams come in real-time analysis. Firehose come in real-time and store it. Now let's talk about Kinesis Data Analytics. So here, it's coming in streaming, and we're going to process it and analyze it with, say, standard SQL or Apache Flink. And it's going to enable you to gain actionable insights on your data, and you don't need to start learning programming languages or processing frameworks because it's kind of built in and fairly smooth. So, because people have a hard time with this. Kinesis Data Streams comes in, analyze real time. Kinesis Data Firehose comes in and stores. Kinesis Data Analytics comes in and it's being analyzed in real time. Then the last is Kinesis Video Streams. So that's a service for streaming video and coming in a secure manner to run analytics on it or machine learning. So what if you had 1,000,001 cameras going on of the country and you could see what was going on in different parts of the world? Maybe because you were expecting bad weather and you've got all these cameras in, and then AI could scan it and say, hey, there's a hurricane in Florida, that kind of thing. Think about how you use these. So I hope that makes sense. Streams, real-time, analyze. Kinesis Data Firehose, store. Kinesis Data Analytics come in and analyze real-time. Kinesis Video Streams come in video and maybe analyze that in real time. So where would you use this stuff? Real-time analytics. Data ingestion for a data lake or a data warehouse, because you can stream data coming in to, say, S3 or Amazon Redshift. Machine learning. So we can take real-time data, stick it into a machine learning model, find anomalies, maybe make recommendations to people, get some predictive analytics because we see something, we think we know something. So, that's going to be really great. It's going to support training FX and inferences based upon real-time data. We may have a lot of Internet of Things devices, like IP-enabled weather sensors or all these airplanes flying through the sky. or your refrigerators that are spewing out information, or medical devices that are connected to the network. IoT devices are becoming very big, and there's lots of them, and they're streaming lots of data. Think about video analytics. Think about security surveillance. You're doing a high-risk thing, and you have machine learning pulling these Kinesis video streams and look and notify security people or something. Think about, giving a presentation and looking at the audience and having machine learning pull this information and say, people don't look happy. Change this, do this, or make recommendations to the speaker. A brand could do that with their brand message. Or being able to pull information and see, okay, there's a process when those cars are being manufactured that's wrong. We found it. Let's go fix that before a car comes off the assembly line wrong. So let's talk about some best practices with Kinesis. You want to optimize your shard count. So shards are a measurement of how much data you can send. You want to make sure you get the right amount. If you don't have enough, it's not going to perform well. And if you have too much, you're going to pay for too much. So either use the Kinesis scaling activity or auto scaling to automate shard scaling, or know what you need. You may want to think about data compression, because you could compress the data before sending it, which will reduce the amount of data that's transferred and stored. You may want to take a whole bunch of smaller records and pop it into a bigger record to optimize performance and reduce cost. So some other things we should think about from a best practice perspective. Make sure we encrypt our data at rest and in transit. So use like a TLS security for in transit. Use the AWS key management system to store your data when encrypt your data when it's stored. Add a good, strong IAM policy to make sure that only the right people can access it that need to. And of course, set up any monitoring alerting. You really want to know when systems aren't doing well. So set up CloudWatch alerts, and based on key metrics like maybe incoming data rate or outgoing data rate, or anything that just doesn't feel right based upon your utilization of these systems. And then test your systems. Regularly test their system, validate to make sure they're actually working, that the data is coming in accurately and the data is complete, and nothing broke along the way. No, I mentioned Kinesis Firehose. Let's talk a little bit more about it. Again, this is more about storing the data as we talk. So, because we're going to capture it and store it, and it scales, that's where we use Kinesis Data Firehose. Now, like all the stuff I talked about throughput in shards, a shard's going to be 1 megabit a second, or megabyte a second. It's not going to be a lot of data, but in streaming data, it's a lot. Things to think about, whether it's Kinesis Data Firehose or other things, is that you're paying on those shards. So you really need to determine what you need. Regarding Kinesis Data Firehose, which is where we take it in and we store it, we can have up to 10 shards per region, per account. Now that doesn't mean you're going to not need more than 10. But that's the default, what you're given. If you need more, you can request them from AWS, and you can usually get some. They're happy to sell you more if you need it, but there's that. And you can set up a policy to auto scale based upon utilization. So you reach a certain level, add more. You can set up Kinesis Firehose from the console. Here's the way that I always looked at Kinesis Firehose in my head. We had our data coming in. We popped it into a bucket. And after it's in the bucket, we run an analytics tool like Power BI or something like that. Gives you the opportunity to look at your data, visualize your data. These analytics tools could have been machine learning or anything like that as well. Let's talk about some key concepts for Data Firehose. The underlying, I want you to think more about the data record. The data that's produced, the data of interest, is going to be considered a data record. And the records themselves can be as large as 1,000 kilobytes. So not that big, but relatively big on something where we're typically talking about text data, or could be text data. Now the data producer that's going to send data can also only send it up to 1 meg. Now, a little more about a data producer. So I want you to think about, with Kinesis, the data producers. So it could be a web server that's constantly sending its log data. It could be its data producer. It could be, clickstream data that's a data producer, like who's clicking on what boxes on a website that a company might track. So you may have to have the engineers that set this up set up the buffer size and the buffer interval, because the Kinesis data firehose is going to buffer the streams to catch a certain size or for a certain period of time. Buffer size will be in megabytes and buffer interval will be in seconds. Now let's talk a little bit more about Kinesis streams. Pretty much every connected device in today's world has an IP address. Cars, smart cars, smartphones, security cameras, your refrigerator that for some reason needs to tell you which foods to buy and text you when you go to the supermarket. Everything now has an IP address, which makes security a lot harder. But, Kinesis video streams can take all these streams. And by getting all this information, businesses can look at it and analyze it. So I wanted to talk about the application first, and then each one of these a little bit. Here's the way you kind of look at this. Here's one possible way. You could take 3 video streams in and then send it over for media processing. You could be taking these video streams in and sending it to AI. You could be taking these video streams in and sending it to multiple people to go look at the video streams or some semblance of what these things are, so they can make decisions on it. You can be sending these streams in and having software that will alert certain people when it sees patterns of behavior or anomalies that don't look right. So lots of cool stuff you can do with this stuff. Bear with me a second. You know what? I think that's a good time for us to take some questions. So while we wait for some questions, if you're having a good time, hit the like button, subscribe to the channel, and hit the bell to be notified of new videos. Amit, is AWS Data Pipeline the same as Azure Data Factory? Yes. AWS calls their data pipeline. Azure calls it the Azure Data Factory. These are just two manufacturers that have their own different versions of basically the same thing. So definitely one is functionally equivalent of the other. Can we say an application for AWS Kinesis is Netflix? Well, yes, Netflix definitely uses AWS Kinesis. And why? Because it can capture real-time data, and they could use it for processing and analytics. They can leverage Kinesis to collect and analyze real-time information based on, say, user behavior. They can monitor the streaming quality with it. They can detect and resolve issues. And if we have to look at Netflix and we look at it, for example, they're a very interesting use case. So yes, they typically use Kinesis for real-time processing analytics, and it's perfect for their use case. But let's think about that use case. If Netflix goes down because the entire AWS cloud collapses, what's going to happen? People won't watch TV. Is that life-threatening? No. Can AWS then be on a single cloud, potentially tolerate a couple hours here and there of downtime, and not have a horrible impact on their business? Yes, they really can. So by being on a single cloud and leveraging some of the proprietary services, Netflix, by comparison, can use this service and be great. Now, let's say by comparison, we have an airline that's all on that single cloud. And they're using all those single cloud proprietary things. And we've got planes in the air, or better yet, not an airline, air traffic control. They're all in a single cloud. And that cloud provider has an outage. Can we deal with airplanes being up in the sky for a couple hours without air traffic control being able to determine where the planes are so they don't crash into each other and be able to determine which airports people can land at? Probably not. So AWS is an example of a wonderful business that is using technology in an incredible way that completely understands their business requirements. Likewise, a hospital, which could be doing surgery on a patient, probably doesn't want to be taken down if they were on a single cloud. So, because people could die. So we have to look at every business. But the example you gave in Netflix is a very special use case. For the most part, they can be down. Their subscribers typically don't go away if they can't watch TV for 2 hours. And there's no major earth-shattering things that occur. And in that example, using things like proprietary services is so awesome because you can make your design more simple and more elegant. So kind of keep that in the back of your mind. Yes, we can definitely say that AWS Kinesis is good for Netflix. Quite frankly, AWS Kinesis could be good for a lot of businesses that only need to do real-time data processing on a single cloud and can use higher availability for other systems as well. Great service to take in real-time data and analyze it. So are the templates talked about in services today in YAML or JSON templates we see in CloudFormation? Mark? I am honestly not sure. Let me think about that for a minute. You know, I'm just not sure, Mark. I don't want to give you bad information. Mr. Dominic, could we say that when we cloud services, we trade convenience for flexibility? Oh, can you, I'm going to translate that, Mr. Dominic. Are you saying that when you use serverless, you trade convenience for flexibility? Well, when you use serverless, here's what you do. You get flexibility. Well, I'm sorry. When you use serverless, you get convenience. What you do is you lose control. So today, a lot of businesses enabled a company to push updates to their Windows computers, automated. And we've had a global outage today because somebody else was able to do stuff to their systems. Businesses that manage their own security and didn't allow that were not affected today. That you're the people that use the different vendors. So here's what happens when you go serverless. You have to create code, typically speaking, that's optimized for one cloud provider, which means if you have problems with a cloud provider, it's going to be very hard for you to leave without redoing everything you have. The second thing that happens when you go with a proprietary anything is all of a sudden there's a desire to innovate. And this person has a better tool than you currently have. Innovation becomes very difficult when you use proprietary tools because other devices can't connect them. So you lose innovation potential. When you use a serverless thing on one cloud, it's going to be very hard to have a backup system running on another cloud. And sometimes it's better and at the same price to put 50% of your eggs in AWS and the other 50% of your systems in Azure as opposed to buying 100% and 100%. So you also trade performance and availability gains as well. So there's a lot that you lose when you go serverless. And there's a lot that you gain. It's simple. It's elegant. You don't need as sophisticated people. I mean, the people that truly understand high availability, high security systems are expensive. People that typically come from that networking background where they're designing this stuff all the time are much more expensive than somebody else. So you can use less expensive people, generally speaking, when everything is managed for you. But it's not the same. You know, my mother-in-law, boy, she makes me a hamburger, and boy, is that thing good. Because she knows exactly the right amount of garlic and salt and pepper and oregano, and she makes it exactly the way I like it. If I were to use a pre-made service by going to buy Burger King, for example, I don't have control over the grade of beef. I don't have control over the spices. So it's not going to be as customized. But maybe that Burger King hamburger is perfect, and maybe it was cheaper and easier to do. So what is it that I really want? Personally, I'm very careful with what I eat, so I don't do managed service anything. But, equivalent of that, I don't outsource like my food. But, everything is a trade, and it's about choosing the correct trade based upon what the needs are. Mark, here's the thing about being 50. Sometimes you have to think about it. So templates for Kinesis are typically written in JSON. They're often written in YAML as well. And they often use these templates to define or deploy resources and say something like CloudFormation or along the way. So templates can be deployed in lots of different ways. But think about a Terraform script or a CloudFormation script, the AWS CLI. Sorry about that, Mark. Sometimes you got to really think about something for a minute or it slips your mind. Is Kafka considered an ETL tool? No, it's more of a streaming messaging type tool to basically push the messages to its end destination. Mark, I always forget that you had that operations perspective where you actually built this stuff, so I can see why you're asking that question. You're a great architect, too. Okay, well, since we talked about Kinesis, let's talk about the other options. So, not every organization could or necessarily should use Kinesis. Some people should use Kafka. And guess what? There's a couple of ways you can do Kafka. You can set up your own Kafka systems, which is option 1. Or option 2 is AWS has a managed system for you. So they have something called Amazon Managed Streaming for Kafka. And what is it? It is a managed Apache Kafka service. So it makes it easy to build and run these applications using Apache Kafka. And Apache Kafka is widely used because it's a popular open source platform to build real-time data pipelines or any kind of application that uses data streams. But here, it's fully managed. So you don't think about setting up your virtual machines, patching your virtual machines, monitoring your virtual machines, running these systems. So it's done for you. And, it provides, good availability and durability of your data. And it's properly managed and done by AWS. So it tends to scale by, if you're familiar with Kafka, you can either add or remove brokers. So it's going to support both vertical and horizontal scaling based upon the workload that you have. It's going to integrate with, it's an AWS tool, so it's going to integrate seamlessly with the AWS Identity and Access Management System. It'll support encryption in transit and at rest using the key management system. That's going to enable you to do some network isolation using your VPC, for example. It's going to give you good monitoring and good metrics, and it's an open standard. So where might you use Apache Kafka? Real-time analytics, streaming data, event-driven applications. You can build applications that respond to something. All this stuff comes in, then do something else. You can integrate it with ETL tools to load your data, say, into a data warehouse or a data lake. Works great with all those IoT devices that are spewing information constantly. So how do you set this up? And it's a little easier than setting up a traditional Apache Kafka setup. You basically create your cluster in the management console. And you can choose between a custom cluster or a quick create cluster. You'll specify your configuration needs, such as the number of nodes you'll need, the type of instances or systems that you'll use, your storage. You set up your networking and security. You'll create the topics and you'll produce the data. So you'll use Kafka clients or libraries to create topics in your managed cluster. And then you'll produce your data to the Kafka topics using the Kafka producer API. You'll consume the data. You'll monitor the data and manage the data, manage these systems. And, best practice was, what are you going to do? You'll look at your cluster. Is it the right sizes? Is it too big? Is it too small? So you typically want to use multiple nodes in different availability zones, so that way you've got higher availability in case one data center fails. You're going to want to implement good security best practices like IAM roles, permissions, that kind of thing, encryption at rest, encryption at storage, and of course make sure the rest of your systems are locked down. You're going to monitor your systems and you're going to scale them appropriately. You're going to try to ensure data availability and consistency and data durability. So configure replication factors. Make sure you've got your minimum and sync replica settings done to make sure you've got your data durability. Maybe use AWS Private Link to enhance security and connect to where the service you need. So that was streaming. Now that was the Amazon managed one. You could still use in a business an Apache Kafka environment where you just put them on virtual machines the same way you did in every other data center. And you might want to do that if you need more control. Let's talk about another AWS data service. And this is the AWS Data Exchange, and I'll explain what this is. It's a service that enables organizations to share data. So maybe I want to share my data or sell my data to somebody else. Maybe I'm in the business of data and I sell data to a lot of people. Or maybe all these hospitals want to work together, exchange data in a secure manner to do medical research together. So that's the point of the AWS Data Exchange. Kind of cool, actually. So if you're in the AWS cloud and there's third-party data in the AWS cloud, this is it. So what happens is you get a data subscription and the user will be able to browse between a lot of data products from lots of different third-party providers. You can find a data product on financial market data, health data, retail data. There's going to be data and lots of people selling data. I think of it as a data mart in my head, honestly, like when you go to the store and you buy something. But the data providers can easily list and manage, store, and monetize, meaning sell their data products. And it's pretty good for the providers as well because they're already on AWS. You've got AWS infrastructure, AWS network, so it's pretty simple to make this work. So you subscribe to this service and you get your data delivered via an object storage bucket, typically in S3. The data is updated every time the provider updates their data or publishes an update. And it's really easy to use. I mean, this is pretty cool. You can go and search and discover other people. It's kind of like going to Amazon.com and saying, I want to buy data. Or putting your data there. And because it's an Amazon tool and it's stored on Amazon, it's going to integrate really nicely and beautifully with things like Glue or Redshift or Athena. So, very nice system. And you'll still be able to use it in other databases as well, but it's a very nice service because lots of people are in AWS. So maybe in financial services, somebody wants to buy market data or economic indicators or gets other data for decision making. In healthcare, data is everything, especially now. Maybe we can get a lot of data which could help with drug discovery. Medical errors are kind of one of the largest cause of death. It's kind of horrible. It's the third or the fourth. Goes in and out whether COVID is up there or not, but it's like the third leading cause of death in the U.S. Maybe the fourth. It goes kind of in that range. So we get access to the data. We can actually mine the data and see the mistakes we're making, which are killing people, and which ones are saving people to make healthcare better. In a retail environment, the better a retailer understands their consumers' behavior, the better information they have or market research, the better marketing campaigns they can make and product customization, that kind of thing. So there's that. So we'll talk about the concept of a data grant. What is a data grant in the AWS Data Exchange? A data grant's like a unit of exchange. like $1 or a Bitcoin, what have you. And it's going to allow the sender to grant the data receiver access to a specific data. So somebody grants it and somebody receives it by caching this thing in. So how's this kind of thing work? You've got the creation and request. The data is going to send, the data sender is going to create the grant, which will generate a grant request, which will be sent to the receiver's AWS account. The data receiver will then accept the data grant to gain access to the data. What's the data set? Okay, so a data set is typically going to be a curated resource by the data sender. That's going to include all the data assets that the receiver will get upon accepting the grant. You go to the store and you want to see what it is. So AWS Data Exchange supports 5 different types of data sets: files, an API, Redshift, S3, and Lake Formation. The data grant will have details like the name and the description of the data grant, then visible to which data receivers. There will be a component of recipients details will be there as well. What'll be there will be the recipient's AWS account ID, and it'll specify how long they have access to the data. So what's a data product? The product is going to be the unit of exchange. A data product will be a product that has data sets. So it's the main thing that's going to be exchanged. So when it comes to the data exchange, we have to talk about publication and listing. The data provider has to publish the data as a product. And then it gets listed in the AWS marketplace as a product in its catalog, like buying something. And each product will be uniquely identified by a product ID. There will be details on the product, which will include its name, a short description, a long description, maybe a data sample, a logo type image, contact information for support, and data about the provider. Okay, so manage Grafana. So Grafana is going to be a service that organizations use to enhance productivity because it helps take away some of the burden of analytics. It's an open source analytics tool. Today, visualize, query, and understand the data. And by being managed, it does that big data analytics. And it kind of helps because you don't have to set up the systems. You don't have to think about it. Grafana is a widely used tool. But with managed Grafana, it's going to be serverless. And by doing so, it's not going to be something that you have to manage. Not thinking about setting up the virtual machines where this runs, what have you. So with a managed Grafana environment, users will be able to easily query, correlate, and visualize operational metrics, logs, traces from a lot of different data sources. It scales well, so you don't have to think about upgrading the systems if you built your own managed system. It gives you a single dashboard where you can look at your tools. Highly interactive for, say, data visualization, and effective for looking at real-time monitoring. Because it's managed, and it's managed by AWS, it typically integrates very easily with AWS data sources. But it also, because it's Grafana, which is open source, tends to work very well with many other open source tools, third-party tools, and common cloud data sources. Now, Grafana kind of supports that SAML, that security association markup language, so it's going to integrate really nicely into IAM systems. It's a secure environment, and it's going to take away the stress of periodic renewals and licensing. And so it's not open source. Sorry. So Amazon managed the Grafana. The key to remember, it's Grafana, but it's managed for you. So no patching, no updates, no backups, none of that. So thinking about where you're going to use this, some of the features and functionalities are going to be under collaboration and sharing. It'll enable you to share dashboards with, say, team members and maybe collaborate on certain visualizations. It will help you control access with fine-grained permissions. Some other thing that is typically is from a security perspective, think about it in encryption. It provides encryption at rest and encryption in transit, so when it's stored and while it's in motion over the network. How do you set it up? You set up a workspace in the management console, CLI, what have you. Usually the management console, you'll set up your basic settings, such as your workspace name, your data source, your permissions. You'll add your data sources. You'll create your dashboard. And you'll set up your alerts. And obviously you'll manage your permissions, what have you. But let's talk about some best practices from the managed Grafana. You want to make sure it's going to perform well. So you want to regularly view and optimize your queries to make sure you're going to have efficient data retrieval. You're going to want to use Grafana's built-in caching mechanisms to reduce the load on the data sources. You're going to want to secure your environment. So, look, there's less security we can do here than in other places, but obviously make sure that traffic is limited by access control as firewalls in places where you need it. And inside of your systems, you're going to implement the principle of least privilege. So regular review, your IAM settings, what have you. It's a managed service, so keep track of your costs. Is it working for you? If not, is there an alternative? Is there a cheaper alternative? And now we will talk about AWS OpenSearch. So you may have heard of Amazon Elasticsearch. This is pretty much the same thing. It's the same product with a new name. And organizations use it for real-time searching and analytics and visualization capabilities from their data. Maybe logs, maybe other environments. So one of the features with OpenSearch is these are managed clusters. So it's automated provisioning, setup, and maintenance of your clusters. Automated backup, automated patching, automated recovery should something go wrong. Because it is automated for you and it is managed, it's going to scale well. It's just about adjusting the number and the type of instances. It's going to support, big environments, petabyte scale data across multiple data centers, availability zones, whatever you want to call them. So as long as the cloud's up for the most part, or the region's up, you should be good to go. Let's think about data security under features. It has VPC support, so you can isolate your data, which means you've got access lists and all that other cool network security you can do. It provides encryption at rest and encryption in transit, and it's integrated with your IAM very simply and very easily. So, integrated with data visualization, well, it comes with OpenSearch dashboards, so any kind of plugin you want to put on there. It also has anomaly detection. So if you're monitoring something and you're looking with it, it's got some AI to help you determine anomalies, which is another nice thing. So how do you set this up? You go to the management console CLI, use the SDK, and you create a new OpenSearch service domain. You configure the instance type, the number of nodes you'll need, the storage you need, the network settings. You configure your security settings, like your IAM profiles, your VPC access, security groups, what have you. You enable encryption options for data at rest and data in transit. You're pulling your data, either things like Amazon Kinesis or ingestion tools like Logstash or FluentD, that kind of thing, or a custom script. You build and visualize your dashboards, and you monitor. But like anything else, you run it, you test it, you see what's going on, you optimize your performance, you tune your shard settings, your query performance based upon the results of what you put out there. Obviously, keep your data secure. Monitor your costs. If these things are going to be running all the time and they run on virtual machines because they're servers, and you need it for a long period of time, maybe you can reserve the systems using reserved instances to kind of help eat the bite out of the server cost. Okay, so that is going to be a natural break because we are going to go next into some identity and access management. So I think we should pause here. Chris, let me know if anybody has any questions. And maybe there isn't, and that's okay too. All right. So if you got a question, ask it now. We can take 10 minutes of questions. We'll start getting to identity and access management. If you don't, that's okay too. Personally, me, I think I start the day with 10 questions and end the day with 1,000,000 questions, and always try to ask as many as I can from the people that I know that can try to help when they can help. So, just in case, let's talk about a few things. We've got another week next week, although I'm going to try to work a little extra fast so we can go Monday through Thursday instead of Monday through Friday, if that's at all possible. But we've got one more week to go, which I'm totally excited about. I love doing these things. And we've got these labs that I'd love you to do. Love you to do them. Got some free downloads for you in the video of this. So the question came in, you desire to learn more and focus on AWS security. So at the ending, we will be talking a lot more about AWS security coming soon. I want to make sure that you realize that there is no such thing as AWS security. There is cloud security. 98% of organizations use multiple clouds. I also want you to understand, and it's a great question, that the same security problems we have in the network and the data center, we still have on the cloud. So, we will need to get involved with next generation firewalls and IDS, IPS systems and SIEM systems and data loss prevention systems. And in most cases, they won't be coming from Amazon. But we will be dealing with some Amazon security tools as well. And the key to remember is it's not AWS security. It's not going to be about the AWS security. It's going to be the tools that are going to make our clients successful. And we'll start with IAM, and we'll get into security. Truthfully, we'll cover much of what's going to be on the AWS Security Advanced certification in this course. And I'll do that because that's that's still not enough security, but I wanted to give you more security than you would get in an AWS certification. And I think you can tell we've gone way above what you would normally get in any AWS certification, but I want you guys to have the knowledge. And I'm thrilled that you're here, you're participating. Some of it gets a little dry, and you're still sticking it in and gutting it out, so you guys are going to do awesome. So thank you so much for that. And but we will definitely get to a lot of security, and I love security. Maybe I'll even do some security things out there coming soon. Got me thinking. Love the concept. So since there was only one person responding, I'm getting worried that you're not awake. So give me a hashtag AWSSAA so that I know you're here. If you're having a good time, hit that like button, subscribe, hit the bell, that kind of thing. And make sure to check out the description of these videos for some free resources. So let's talk about some IA. Okay, actually, I think there was one more question that came in from Amit. Hope we can answer. Would Kinesis and Managed Kinesis be functionally equivalent? Yes. Would Kinesis and Managed Kafka be functionally equivalent? Well, slightly different. They're very similar in what they do. Very similar. But Kinesis is an AWS proprietary product, and Kafka is a product that works on all clouds everywhere. And it's kind of like comparing a Chevy to a Ford. Functionally, yeah, they're the same, but each car might be designed a little different, might be a little better, a little worse, that kind of thing. And the key one is that is better or worse for what? A Mercedes like I have is smoother on my back. It doesn't hurt. It doesn't perform as well as a BMW, which performs better, but my back hurts sitting in it. So it's all about, finding the right thing for you. So I'm seeing that AWS SAA. And Amos, you got Feldman. Oh, awesome name. I know a lot of Feldmans. And, I know exactly what it's like to get your caffeine. And I definitely will do a song of mine. Anybody that sees me drink coffee in the morning plus green tea, they know I have a little bit too much caffeine. So we're now going to talk about identity and access management, and we're going to make sure you understand this because so many people are confused by this. Identity and access management is three things. Who are you? What are you allowed to do? And what did you do? So That's the key. Authentication is, are you who you claim to be? So Mr. Singh Binner, who's in this, I know him and I know him well. He's awesome, by the way. But if I'm trying to have a conversation with him, I want to know that he's him as opposed to Hal the hacker. So the authentication is you proving who you are, you claim to be. Now, next is going to be authorization. So authorization is what are you allowed to do? So I see Mark over there in San Francisco is here. I know Mark. If Mark came to my house and I gave him the keys to the car and the keys to my house and I said, you can come in and do whatever you want, because I know him, he and his family are great, that would be one level of authorization. By comparison, somebody may knock on the door and they might say, I need to use your phone. And I might walk them to my phone and stand next to them. They're permitted to use my phone, but not necessarily to come into my house. That's authorization, and we'll walk through that a little more. And accounting is, what did you do? And that way they can track the things that you've done. So Mark came to my house. Let's say he came over from San Francisco, stayed with my wife and I. When he left, my wife is going to say, oh, wait, we need 3 new bars of soap, a new bottle of shampoo, and she's going to go to the store, Publix, because that's her favorite supermarket locally. She's going to buy it, and she's going to restock the house. That is the accounting. So I hope that makes sense, because there's lots of confusion there. Now, as a rule, and we'll specify all the millions of exceptions here, AWS defines something into users and roles. So for the most part, at the solutions architect associate level, a user is a person. Mark's a user. Mike's a user. Hal's a user. Nico's a user. Vageli's a user. Maria's a user. So a user is a user. Typically speaking, for the solutions architect associate, it changes with the professional. Like my physics teacher said, education is an ever-decreasing number of lives. The more you know, the more specific it gets. But at the associate level, a role is for one system to typically connect to another system. So you may have heard of a service account in Linux or a service role in Google. It is the same thing as a role for the most part, in most cases, but not always. So this is identity and access management in action. You got a user. You sign into the management console. They provide maybe a username, maybe a password, maybe a token, and they are now allowed entry. Next you see is authorization. That's where when you try to access the system, and it either allows you to access the system, or it gives you the access denied kind of thing, and it doesn't let you go based upon your authorization. And accounting is keeping track of that. So I hope this makes sense. Keeping track, a log of everything you did. So let's talk about IAM users. They are identities, hence identity and access management, that have the permission to interact with an AWS resource. So who creates these? People with administrative access, or principals with administrative access. I didn't make up the term. And an IAM user can be created in the management console, the thing you go click the boxes on, the CLI, or via the API. And here's something to remember from a security perspective. An IAM user is permanent unless you delete it. So if a user quits the organization, you have to take away their access. Otherwise, they will still be able to access the systems. So here's the way that I would look at it. Somebody logs in and they are given access to specific resources. You can access this thing versus the other thing, but not everything. So I kind of hope that makes sense to you. So let's talk about authentication. How do you know that the person is who they actually claim to be? Well, there's lots of ways to do it. I know Mark, who's on that chat box. If I see Mark, I know who he is because I know who he is. I recognize him. But, we don't typically use that when we log into one of these systems. So we can log into the management console with a username and password. That worked great. Username and password. But is that the most secure system? Especially we may have a user Sally and a password Cat. So Cat is very susceptible to a password, to what's called a dictionary attack or a brute force attack. So please don't create a password called Cat. But that's neither here nor there. So passwords are problematic. The next option we have is we can prove who we say are with something like an access key. And an access key is going to be a 20-character key ID and a 40-character secret key. So lots of long keys here. And the access key will be used to connect to AWS via an API. And this is generally performed with the software development kit over an API call. We can also come in with an access key and a token. For example, when IAM authentication needs to occur under an assumed role, which is, well, maybe we shouldn't go right here. But what will ultimately happen there is maybe you go in and you're using some form of a federated identity management, or you're going into a cross account and you're assuming a role of something. So you can use a session token with the access key. So now you've got a token and an access key. So it's additional security over the other methods. So that's authentication. Are you who you claim to be? Now, in reality, in our architectures, we can use the iScan for authentication. We can use a thumbprint. We can use something you have and something you know, like a password and your thumbprint. We can use something you are, like your iScan. So there's lots of options that we can use as a rule for identity and access management. But for the AWS exam and for AWS IAM services, those are our options to log into at least our AWS account. Now that's authentication. So let's talk about authorization. Authorization will occur by giving you specific privileges that will have been defined by the identity and access management thing. So you write a policy. Alonzo can access this, but not this, or all of this, or what have you. So you create a policy. Now, I can create a policy one of two ways. I can create a policy for Alonzo, a policy for Chris from my team, a policy for Mark on my team, or I could all say they're all C-suite users and create something for the people that are in the C-suite, chief marketing officer, chief operating officer, chief technology officer, and say all of them get access to the same level of things. That's called role-based access control. And in a small company, it may not make sense. In a big company with 100,000 employees, you don't want to manually assign 100,000 different sets of permissions. Now, on AWS, IAM policy documents are going to be written in JSON, JavaScript Object Notation. And the good news is, like any security thing, the default policy should be to deny. So the default policy is to deny access to services. So you're going to have to configure what you want to allow. So you're going to create a policy. And what you're really giving it is a couple options. And in these policies, you're basically going to say, do I allow something or do I deny it? And, what is the service we're going to be able to access? So when you want to give a granular policy and you're going to use a service, you're going to be putting in what's called the Amazon resource, the ARN number, the resource identifier. And that's where you're going to get very specific with what you actually have here. Because, you allow certain things like an effect, which is you've got certain things that you can actually control. But what is it access? So you're going to provide actual granular access to what you want. Of course, you could just provide access to allow almost everything, but that would kind of mitigate the need of doing this. You want to be very granular in what you allow. So we're going to specify an action, which is really the permissions of the user. Can they read? Can they write? We can get optional conditions. So we can get even granular, like a specific subnet at a specific time of day will be able to access these systems. See if I can show you this, because here's what a full IAM policy might look like. Never mind, I don't think that's going to be helpful. So here's what I kind of meant about limiting permissions. So we're going to want to limit our permissions to the least amount someone needs. When it comes to security, you don't want to give people more access than they need to know. You're not going to be allowed to walk on a certain part of a military base unless you need access to that certain part of a military base, because it's a secure facility. So it's the same thing digitally. Give people access to the least amount of privileges they need to do their job. Why? Because when people have more, they will go out there and they will find some way to accidentally break the system or hurt you. So that's why businesses do this. So here you can see a user wants to access the system, and they go over and, they can access S3, no big deal, they're authorized. They can access DynamoDB, but when they go to that management console, they are not allowed. And why might that be? Maybe the user needs access to the data in object storage. Maybe, just maybe, they need to be able to look at the database and run a query, but maybe they don't need to be able to create user accounts. So, they wouldn't have access to the management console. So let's talk about some key concepts that you should think about as you think about AWS and identity and access management. We have some things we have to define. We have to define what is a principal. And a principal is going to be the IAM entity that we're actually talking about. And that entity is going to be something that has permission to access the AWS cloud. So it could be the root user. That's the king and the queen of everything. And we'll talk about that in a minute. It could be an IAM user of any user that's created. Or it can be a role. One system attaching another system or some form of federated identity. The root user, well, that is the user that can do anything. That's the user that created the account. If you're the root user, you could literally speaking delete your entire account. That would be pretty bad, right? Kind of like when the Google Cloud deleted and accidentally deleted a $240 billion hedge fund. Like that. Well, here's the key. That root user has unrestricted credentials, which means they can damage things even accidentally. So don't log in with root. Where have you heard this before? Don't log into your Linux system with root. It's the same reason. Now, because that root can delete the account, don't give the root access to everybody else, and don't do the user root password cat, because this is the thing that you need multi-factor authentication, super strong passwords, all of it. Hope that makes sense. And don't use root access. I think it probably goes without saying for programmatic access. So don't let this system talk to this system with root access. Here's always been the way I've always viewed root in my head. It's that king or queen that can literally do anything they feel like. Unlimited privileges inside of their systems. So there is that. But if you have to protect the king or the queen, what do? You typically speaking have lots of security. So be real secure with that root account. Now, when it comes to AWS, they use standard concepts like users and groups and access control policies. So a user is a person. A group is a group of users. So we have this concept of role-based access control. Here's what role-based access control is. Option 1, I assign manually to every single person. Do you think that's going to work? Really? What if you're Amazon and you have 1.5 million employees? Do we have somebody sitting there all day long? Hold on, I got to go type in these usernames and accounts. And, 100 people leave and they got to remove them, and 100 people come and they're all day long. Click, 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 click. Okay, no, we're not going to do that. So what might they do? They might have sales reps that get put in one group. They may have cloud engineers, which puts in another group. They may have solutions architects in another group. They may have software developers in another group. And that determines who can access what. They may have network engineers that build the AWS cloud and make sure that it runs in another group. So here's how it works. Create your groups of users, add permissions to the groups, and add your users to the groups. That's it. That's role-based access control. So AWS supports that very well. Now I'm going to talk about IAM roles. And for the most part, for the associate exam, what you're dealing with is users are people and roles are systems. For the most part, for the associate. Now, if you're going to take the AWS Solutions Architect Professional, or actually want to function in the real world, you're going to need to know a little more about these types of roles. So we're going to go talk about it the way we would in the professional exam. So we have a couple kinds of roles. We have what's called a service role. And a service role is when you have one system accessing another system, kind of like a service account in Linux. We also have what's called a cross-account role. So what is that? So let's say I am a car manufacturer and I have a tire dealer. We might want to create some strategy where the car manufacturer can log into the tire manufacturer's information so they could see the type of tires that are available and the pricing of the tires. So a cross-account role is when you go from one account and you get permissions to go into another account. That's a cross-account. Service role, one system to another system. Cross-account, one account to another account. And next is identity federations. Seriously, do you really believe that anybody's going to go in there and start configuring these AWS identity and access management systems at an enterprise scale? Or does the enterprise already have a Microsoft Active Directory structure set up where it's got all of its, 100,000 employees already in Active Directory? So what we're more than likely going to do in the real world is we're going to federate the AWS cloud into something like an Active Directory, where the organization maintains their own identity and access management systems, and they integrate it. So when you log into, say, Microsoft Active Directory, it'll automatically log you into AWS for you, like a single sign-on approach. Now, roles, especially a federated role or something like this, tend to enhance security because we don't need to put, say, AWS credentials on one system that's attaching to another system. We're generally not putting a password in one system to go into the other system. We're going to use temporary tokens, where it's these tokens periodically authenticate. And that way, if a token's good for an hour, just for example, and a hacker gets access to the token, by the time that hour is over, it'll be gone. They won't have access to the new one. So worst case scenario is the length of the token. But of course, if it's a 60-minute expiration and they attacked it at 56 minutes, that token's only going to be good for 4 minutes. Of course, if they attacked it at minute 1, it would be good for 59 more minutes, assuming the token expires in an hour. And these are configurable settings. So tokens are rotated frequently, and no long-term credentials are stored on the server. So these service roles tend to be very good. And the key to remember is roles are used for either a system to reach another system. They are used for an application to connect to another service. They are used to connect to another account, and they are used under federated identity and access management. And tokens are temporary and expire, and the default expiration time is actually 60 minutes. But you could set that token to 15 minutes for a really high security environment, or 36 hours, for a different type of environment. And typically roles are used to grant permissions for one system to another. So now let's talk about that AWS Security Token Service. So that's going to be a web service that's going to enable you to request limited privilege credentials, so a token, or use federated identity access management users. So credentials will be used to access AWS resources. And the rate when you don't want to use long-term credentials like a password inside of the system. Some things to think about the AWS Security Token Service are temporary credentials. They provide very temporary security credentials that include an access key ID, a secret key, and a security token. And these credentials are short-lived and they automatically expire, so they protect you should a hacker get access to it. There's this concept of the IAM role assumption, and what's going on here is it allows users or services to assume a role or an identity to get temporary credentials. And this is going to enable, say, a cross account where you're at that, again, like at that auto manufacturer trying to get into that, say, tire manufacturer in the least amount of privilege possible. Federated user access. Have you ever logged into a website and it says log in with Google or log in with Amazon or Apple? Your Apple ID, that's federated identity and access management. Or it's logging into the Microsoft Active Directory, which enterprises typically use. And that uses SAML 2.0 typically, or OpenID Connect to identity providers. Security token services give you very fine-grained access control. So where might you use this AWS security token service? Well, with cross-account roles, one role going into another. In any kind of federated access environment, connecting to, say, Active Directory. Mobile and web applications, you might use something like this because you may want to provide temporary credentials for a mobile application or a web application, because that's going to reduce the risk of putting or embedding long-term credentials in your applications themselves. Anytime you want to give short-term access to grant, say, temporary access to AWS resources to maybe a third-party vendor to come in, you want to be very careful about the access you give to third-party vendors. Very careful. So how do you set this up? Well, for the AWS security token service, you basically create an IAM role. And then you'll do that in, say, in the management console. You'll go to the IAM section and create a new role. You'll define the trust policy. So, meaning who can assume the role, which users can go where. You'll attach the appropriate permissions to the role. And then when it's time to assume the role, what'll happen is, typically speaking, your APIs will do this for you. But if not, what you could do is you could go to the AWS command and you can assume a role. And what's happening when you assume that role is it's going to send a request to the security token service. And that's going to basically use this role learn parameter. And what it's going to do is it's going to specify something like the Amazon resource name of the role you want to assume. And I showed you those Amazon resource names when I showed you the identity and access management policies. And that was that thing with the ARN : AWS : IAM, that sort of thing. Some things to keep around here and think about when you set these things up, or best practices, are to give the principle of the least privilege. You want to really define these roles very granularly and don't give access to more than you need. Use very short-lived credentials. Use the shortest possible duration for temporary credentials because you want to minimize security risks. And you want to regularly rotate temporary credentials, because the longer these credentials are good, the longer the time somebody has to get them and then use those credentials to access your systems against you. Monitor and audit your systems. Enable monitoring and monitoring of your AWS STS APIs. Log it onto CloudTrail. Review those CloudTrail logs and monitor role assumptions and temporary credential changes. Are they ones they're supposed to be? Use secure protocols to connect for federated access like SAML 2.0. Use multi-factor authentication with the identity providers for added security. For example, in a single sign-on environment, or in any one of these roles that we're going to assume, if we get access to the systems and via a weak username and password, we may be able to access everything on the end state, especially with single sign-on, where you sign into one and you get access to everything. So make sure the authentication is strong, maybe like multi-factor authentication. Bear with me one second, I want to think about something. You know what, I will cover cross-account roles, and then we'll get into managed policies tomorrow. So I know I briefly talked about cross-account roles, but Cross-account roles basically give you access, and I mean Monday, not tomorrow. Cross-account roles give you access from one AWS account to another. And this can enable businesses to collaborate. So think about this. You allow someone access into your facilities or your systems. They can help you. They can hurt you. If you connect to another account and they get hacked, they can hurt you. So we have to think about all of these security-wise. So it's not just IAM. It's going to be the networking side, the security side, firewalls. There's lots that needs to be done to go from one account to the other. This is just on the who are you, what are you allowed to do kind of thing. What have you done? So when we deal with cross-account roles, we have to be very concerned on security. We at minimum need to focus on that principle of least privilege, but we may need other types of security along the way to connect from one account to another account. So when it comes to cross-account roles, you may hear the concept of an external ID. And an external ID is going to be a secret identifier that is known by you and the third party that you're connecting to. And you need to be able to specify this ID when you just specify what's called a trust policy. And a trust policy is related to exchanging of information, typically in identity and access management systems. If I trust you and you trust me and somebody asks me a question, then you trust that I authenticated them accurately enough to let them into your system. That's typically trust environments. So here is a visual example of what this looks like. You've got multiple companies, and you may let them into your VPC or agree to share information with them. So how do these cross-account roles really work? A role is created for the external user. The external is going to connect to their AWS secure token service, and they're going to get a temporary token. And then the user will provide that temporary token and be given temporary access to the end user's VPC or account. Actually, I'm going to just briefly touch on service roles. I know I mentioned it before. So I like to think of a service account because I used to love playing with Linux, and you could have one account that would connect to another account, and they would call it a service account. Never used Linux in my job, but I always thought it was fun and cool, so I always just loved Linux. So, but it's not part of an architect's career. So we may have one system that's attaching to another system and need to be able to do that. And that is going to be called a service role in AWS, service account on Linux. But think about where you may use this. You may have one application that needs to make a secure API call on another one. You may want to be able to post messages into SQS, the queuing system we talked about yesterday, or the day before. It could be yesterday. You may want a virtual machine to be able to store something in an S3 bucket. You may want your application server to integrate into your database. So that's typically where you would do a service role. Let me show you what that looks like. Virtual machine, accessing DynamoDB, definitely a service role. Okay, so we have gone till 5, which is what I promised, and I'm going to try not to get everybody out too late. But do you all have questions? Any questions you want, I'm happy to answer them now. Let's see. And if you're having a good time, hit the like button. If you haven't downloaded any of our labs, please do, or signed up for our pre-labs, please do so. So, Fa has a great question. Who usually creates the IAM users or roles in AWS? So, generally speaking, we have systems administrators that create users and remove user accounts. They're typically the people that do it. So, architects design your systems, engineers build and performance tune your systems. This kind of add user, close user, doing simple install of an application is typically done by a sysadmin. In the cloud, they would call it a cloud admin, but it's really the same job for the most part as a sysadmin. They might be setting up the Linux machines, patching an operating system for Windows or Linux. But it could be the engineer that's actually building it. Or in all seriousness, yeah, it's typically going to be done by a systems administrator. But the reality is this. Most businesses are going to be using some form of an enterprise identity and access management platform like Microsoft Active Directory. So what will ultimately happen is someone will be setting up the federation between the Active Directory and AWS, and that would probably be a cloud engineer because it's going to need more sophistication in most cases than just the cloud admin, which is more that technician, they add users, patch kind of thing. Good question there, Paul. Can I define SU to root? So, generally speaking, SU, it could mean switch user, but it's really super, like SU goes up to super user, which is how you change into root, for example. So you would do an SU, and then you could change your user. Typically, people might do a sudo, sudo, and that would enable them to obtain root permissions to actually be able to do things. But SU is just to switch users. But typically, if I'm the user M. Gibbs, the only time I would probably do SU for me is to basically be root to update my system. But I could be logged in. Let's say I had a Linux machine. I used to. And I had lots of Macs, and I could be logged in, and maybe my wife would want to go to my machine and SU and go to L. Gibbs versus M. Gibbs because she's Lisa Gibbs. So that could be a possibility. But SU is more about switch users. But we typically SU, and then we go to root, and then we go to the root password. But sudo is a much better way to do it. Sudo enables us to go to have root permissions, to do an install script, access the system, without becoming root where we can accidentally delete the entire system and be logged in as a different user and not have access to our own data. Well, we kind of could, kind of would. Good question. What kind of directory server on AWS uses? So I don't know what you mean. Are you asking for AWS, the cloud provider themselves? Or are you talking about AWS Directory Service, which we'll talk about, which is basically them having Microsoft Active Directory servers that then they do manage for you? So there's that. Because, you know, AWS is a managed Microsoft AD, which is they manage your Microsoft servers for you. And then there's kind of like a simple AD, which is a standalone managed directory. And then, of course, there's that AD connector, which if you've got your Microsoft Active Directory servers in your data center, you could use that AD connector to connect your Microsoft Active Directory servers and your data center to the to the AWS IAM system. I hope I can help you become a cloud architect or similar. Amos, I can easily help you become a cloud architect. I've trained people that work at Apple, Amazon, Cisco, IBM, Microsoft, Google, Accenture, Deloitte, Capgemini, PricewaterhouseCoopers, Barclays Bank, JP Morgan Chase Bank, Zscaler, Palo Alto Networks, everywhere. I will tell you right now, becoming a cloud architect is not about certification. So what I would like you to do is as follows, and I'd love to help you, and I can easily help you. First, get the completely free ebook on how to become an architect. My team will pop it in there right now. And secondly, join me next Thursday. Next Thursday, we're going to have a How to Get Your First Cloud Architect Job webinar. We will go over the role. We will talk about everything we do, all the skills you need, and we will list them. Now, we'll tell you how we typically teach them, but we'll tell you what those skills are, and you can choose to get those skills from other providers as well, universities, presentation skills coaches. But You'll know what is the role, and you can easily get it. And it doesn't matter your background. I mean, it just doesn't care. I don't care if you're Richard Ferrari, who we trained, who got his first job in tech as a solution architect at MUFG. I don't care if you're Lenny Burnett, who was our video editor, who left us with a solution architect job. I don't care if you're Jermaine Houston, who was selling landscaping gear before we got him hired as an enterprise architect. I don't care if you're Jennifer, who we trained and got our hired from a mental health tech to a solutions architect with JP Morgan Chase. I don't care if you're Yvonne Tambor or Coyote or Jordan Kikitko, who were college students who left our program as solutions architects with AWS. I don't care if you're Daniel Bosu, who got hired by JP Morgan Chase. I don't care if you're Al Legister, whose first tech job was a senior solutions architect at Deloitte. And I can give you examples all day long. Yes, you can, and we would love to help you get there. But I want you to know what is the role, and that way it's all about getting the right skills. And you will have a job that you absolutely love, because it's the best job out there. So, I had a good week. I hope you had a good week. I hope you guys learned this week. I hope you learned some things that were in the Solutions Architect certification. But I hope you learned a lot more. I hope you learned about some best practices and things. I hope you learned about what some of those virtual machines were by coming into our data center. I hope you learned a lot of things. Maybe learned something about Kubernetes, which is not even covered in this exam for the most part. I hope you learned some things about networking, and specifically in the cloud, because we went way deeper than we could have. So you had a good time. Please give it a like. If you've not done the labs, please go sign up for the labs. They are 100% completely free. And I had some fun. Give me a hashtag, AWS SAA. I'm proud of you all for hanging around here all day, all week. Well, we got pretty geeky diving into the stuff. We'll leave the content here if you want to go through it again. Keep that out right. We're going to add, obviously, much more security and many more other things networking. So I hope you're having a good time. I'm honored and privileged to be with you. So have a great weekend. I see those SAAs are popping up. I'm so happy to see that. And I will see everyone on Monday.